What if I told you that every time that Netflix, Spotify, or Amazon go down, it costs them $1 million every minute? But what's stopping that from happening? A quality backend. While sleek frontends catch the eye, it's the backend that keeps everything running smoothly, handling data, security, and performance behind the scenes. And here's the good news. Backend development isn't as complicated as it sounds. You don't need to be a genius to get started. So, hi there, and welcome to my first ever backend course, where we're skipping the basic CRUD tutorials and diving into the real stuff, building a production-ready subscription management system that handles real users, real money, and real business logic. This is the real deal, and today, you'll learn all of it, from what backend development is and how servers work under the hood, to how you can authenticate your users using JWTs, hook up a database, create models and schemas, integrate with ORMs, and structure the architecture of your API to make it communicate with the frontend. Then we'll go hands-on with the JavaScript mastery style and build a secure, production-grade subscription tracking API with advanced rate limiting and bot protection using ArcJet that helps you secure your whole app in just a few lines of code. Database modeling and relationships using MongoDB and Mongoose, efficient user CRUD operations and subscription management, global error handling, input validation, and middleware integration, implementing logging mechanisms for better debugging and monitoring, and automating smart email reminders with workflows using Upstash, allowing you to schedule notifications or any kind of business logic you can think of. And to top it all off, we'll take everything we've built and deploy it to your very own dedicated scalable VPS server. Yep, you heard that right. Your own freaking server with full root access using Hostinger VPS. This will give us full control to deploy your API however you'd like. How awesome is that? This video is your one-stop shop for becoming a real backend developer. No fluff, no shortcuts, just everything you need, all packed into one epic video. So, what are you waiting for? Let's break the backend system that is hosting this video by building this app together. Have you ever wondered how the apps you use every day actually work behind the scenes? From ordering food to sending messages or streaming videos, there's a lot happening under the hood that most people never see. While the front end looks sleek and interactive, it's the back end that keeps everything running, handling data, security, and performance. And if you've thought about getting into backend development, you might feel like it's too complex with servers, databases, APIs, and authentication to figure out. But here's the thing. It's not as complicated as it seems. And today, you'll learn it all. So let's break it down. The web is split into two parts, the front end and the back end. The front end is all about user experience with three key parts. The user, which is you, me, or anyone interacting with the app, whether scrolling through Instagram, reading a blog, or watching one YouTube video after another. The client, which is the device or an app like your browser that connects us to the web. And finally, there's the interface, the layout and the design we interact with, built with Next.js, React, or good old HTML, CSS, and JavaScript. Think of the client, your laptop, phone, or tablet, as a bridge connecting you to the internet. But where does that information come from? And how does it reach you? That's where servers come in. A server is just a powerful computer designed to store, process, and send data. It's a real machine sitting in a data center somewhere that you can own or rent through services like AWS. On the server, we store the backend code, the logic that handles everything from processing data to managing users and interacting with databases. So, how does your device, the client, communicate with a random server to get things done? Well, here's how. Well, first, you make a request. When you visit a website, search for something, or log into an app, your device sends a request over the internet. Then that request reaches a server, which processes it. This server could hold website data, user accounts, or even real-time NVIDIA stock prices when DeepSeek got released. And finally, the server responds. Once it processes your request, it sends back the data, whether it's a web page, search results, or your messages. So, in the next lesson, let's dive deeper into how all of this works under the hood. The entire handshake between the client and the server happens in a flash, faster than Thanos can snap his fingers. But for it to be that quick, computers need to speak the same language. Just like we have different languages, computers follow rules of communication called protocols. And the most important one, HTTP, Hypertext Transfer Protocol. It's the backbone of the internet. When you type google.com in your browser, it uses HTTPS, the secure version, to talk to Google servers. But before your device can send that request, it needs to find the server. And that's where DNS comes in. We use easy-to-remember names like google.com, but computers need IP addresses like 192.168.1.1 to find each other. And the domain name system, or a DNS, is like the internet's phone book. It translates domain names into IP addresses. Here's how it works. You type in google.com, the browser checks if it already knows the IP, and if not, it asks the DNS resolver. The resolver searches for the IP address, and once found, your browser uses that IP to connect to Google servers. But what's an IP anyway? An IP address is a unique number that identifies every device on the internet. Think of it as your device's home address. There are two types, IPv4, which is a classic format, but we're running out of these, and there's IPv6, which is a newer format designed to support more devices. So, now you know how your device connects to a server. But how does it know what to ask for? That's where APIs come in. We've talked about protocols, the rules for how clients and servers communicate. But how does your app actually talk to the backend? Well, that's where APIs come in. An API, which stands for Application Programming Interface, is like a restaurant waiter. You, the client, are hungry and you want to place an order. The waiter, which is the API, takes your order to the kitchen and brings back your food. And then the kitchen, which is the backend, actually prepares your meal but never interacts with you directly. And in tech terms, you would be the client, in this case the app or the browser. The waiter would be an API that sends your request to the backend and returns the response. And the kitchen would be the actual backend that processes the request and sends back the data. So, for example, when you scroll through Instagram, the app's API fetches new posts from the backend. And when you check for the weather, the API pulls the data from a weather service. Without APIs, your app and server wouldn't be able to communicate. They keep everything in sync. And APIs follow a specific structure that helps us manage and manipulate resources, be that data or objects that can be created, read, updated, or deleted. This is often referred to as CRUD. So let's break down the key components. First, we have HTTP methods, or often called verbs. APIs use HTTP methods to define what kind of action to take on a specific resource. Let's go back to a restaurant example. A GET request would retrieve the data from the server, like looking at the menu or fetching the data. A POST request would create a new resource, like placing an order or adding new data. A PUT or a patch call would update an existing resource, like changing your order before it's made, which modifies the data. And a delete request would remove a resource, like you don't like your food and you cancel your order, which deletes the data. Alongside these methods, APIs also have endpoints. An endpoint is a URL that represents a specific resource or action in the backend. It's like telling the waiter exactly what you want from the menu. For example, GET users would return a list of users. POST users would create a new user. PUT user's ID would update a specific user, and delete user's ID would delete a specific user. Later on, we'll dive into the best practices and naming conventions behind APIs endpoints. APIs also have headers, and headers contain extra information like metadata about the request or a response, like authentication tokens, content type, or caching instructions. Later on, when we develop our great subscription tracking API, we'll use an authorization header that'll include your bearer token that verifies your identity. Now, let's talk about a request body. When you use a post or a put request to send the data to the server, the details go into the request body, usually in a JSON format. So when you're creating a user, you need to pass the info from the front-end form to the backend API in form of a JSON, like a name and an email. There's also a response body, which contains the data the server sends back after processing that request. So for example, if you're trying to fetch all the users with the getUsers call, the server might return a JSON that would look something like this. All API calls also have something known as status code to indicate what just happened. 200 means okay. 201 means that you created something. 400 means that something went wrong, and our well-known 404 means that the resource doesn't exist. Another common one is 500, which is an internal server error saying that something went wrong, but we don't really know what it is. And if you want to know more about status codes and all related components of APIs or best practices for writing better APIs, you can check out the complete backend cheat sheet I've created for you. It's completely free, and I'll link it down below this lesson. But with that in mind, that's how APIs work behind the scenes. But I know we've covered a lot of stuff, so let me recap. When you make an HTTP request, here's what happens. First, the client sends a request to the server using the HTTP protocol. This request contains the HTTP method, like get or post, the API endpoint, which is the full URL path you're calling, the headers, which is the metadata, like auth tokens or content types, and finally, the body, which is the actual data being sent for post and put requests. After that, the server then processes the request and sends a response that includes a status code indicating success like 200 or an error, maybe a 404, as well as the body returned by the server, often in JSON format. That's it. That's all that APIs are about and what they're made of. Now that you understand how APIs work, let's explore the different types of APIs you'll encounter. First and most popular are RESTful APIs. A REST, or Representational State Transfer API, is the most common thing you'll see. It follows a structured approach where clients interact with resources using URLs and standard HTTP methods like get, post, put, and delete. They're stateless, which means that each request is independent and doesn't rely on previous ones. And they typically use JSON, making it super compatible across all apps. They're organized, predictable, and easy to implement, which is why they're so widely used in web development and the reason why you'll learn how to build one yourself today. There are also GraphQL APIs developed by Facebook, which offer more flexibility than REST APIs by letting clients request exactly the data they need. Instead of multiple endpoints for different data, GraphQL uses one /GraphQL endpoint. And then clients can specify the exact fields they want without them being previously defined in the code, which is super efficient for complex applications with lots of interconnected data. So GraphQL really shines when you're dealing with large datasets or need to reduce overfetching or underfetching data. But to build any of these APIs, you'll need a backend language. So let's explore a few. To build your APIs, you could use languages like Python, Ruby, Java, or JavaScript runtimes like Node, Bun, or Dino. And if I had to quickly show you how to create a simple Node.js server, it would look something like this. It's a big mess. Writing all of this code from scratch might feel a bit too much, right? And that's where backend frameworks come in. Frameworks provide a structured foundation for building servers, and they handle repetitive tasks like routing, middleware, and error handling so you can focus on your app's unique logic. Some of the most popular backend frameworks are Express, Hono, and Nest.js for JavaScript, Django for Python, Ruby on Rails for Ruby, and Spring for Java. In this course, we'll of course stick with the most popular JavaScript framework, which is of course Express.js. But if you'd like me to see Trihono or Nest, you can let me know down in the comments. But building a backend isn't just about creating API endpoints. It's about managing data. You might think, well, why not just store the data directly on the server? Well, that's inefficient and doesn't scale as your app grows. That's why every backend relies on dedicated storage solutions, commonly known as databases. So in the next lesson, we'll dive into exactly how databases work, the different types you can use, and how they connect with your APIs to manage data efficiently. Let's keep going. Now that you know how APIs work, let's dive into one of the most critical parts of backend development, databases. At its core, a database is just a system that stores, organizes, and manages data. But let's break it down into simpler terms. Think of a database as a specialized software that lives on a computer somewhere, whether that's your laptop, a company server, or a powerful machine in a remote data center. Just like your laptop stores files on a hard drive or an SSD, databases store data. But here's the difference. Databases are optimized for speed, security, and scalability. So whenever you log into Instagram, check out your bank account balance, or book a movie ticket, a database is working behind the scenes to fetch, update, or store that information. And databases come in different flavors, but they're broadly classified into two main types: relational and non-relational databases. Relational databases store data in structured tables with rows and columns, much like a spreadsheet. Relational databases use something known as SQL, a structured query language, which allows you to query and manipulate data. And most popular SQL databases are MySQL or Postgres. You might want to use those when your data is highly structured and relationships between entities are important. Think banking systems, e-commerce platforms, or inventory management. And if you're looking to learn SQL with the latest ORMs like Prisma, check out my SQL databases course on jsmastery.pro. I'll leave the link down below. But with that said, let's explore non-relational databases, also referred to as NoSQL databases. They offer more flexibility and don't rely on a rigid structure of tables. They handled unstructured or semi-structured data, making them perfect when data relationships are less complex. There are also subtypes of NoSQL databases, such as document-based like MongoDB, which stores data in JSON-like documents, and there's also some like Redis, which store data in simple key-value pairs. NoSQL databases are great when handling large volumes of data, real-time analytics, or flexible data models. Think social media apps, IoT devices, or big data analytics. And like with the SQL course, I also have a short and sweet course on MongoDB with Mongoose that covers everything from database basics to building a cool app. So if you're into NoSQL databases, check it out. Once again, the link is down below. So let's be honest, which one is better? Well, unfortunately, there's no one-size-fits-all here. It depends on your business needs. But let me keep it simple. If you need structured data with clear relationships, go with relational or SQL database. And if you're handling massive unstructured data or need flexibility, go for non-relational or non-SQL databases. How would you actually make your backend application interact with that database? Well, the flow is the same for both. First, the client or your device sends a request to the backend. For example, give me all my subscriptions. Then the server processes the request and determines what data is needed. Then the backend sends a query to the database to fetch, update, or delete that data. For example, in SQL, that might look something like this, where you select everything from subscriptions where user ID is equal to something. And in NoSQL like MongoDB, it'll look something more similar to what you're used to. db.subscriptions.find, and then you pass in the user ID. Either way, the database will return the requested data to the server, and then the server formats that data, usually as JSON, and sends it back to the client. So that's it. You just learned how your server or your app interacts with a database, and that is through queries. We use queries to store, retrieve, update, or delete data in databases. You could use raw queries like these ones here, and writing those gives you full control, but also it can get a bit tedious and error-prone as your project grows. That's why many developers decide to use ORMs, Object Relational Mappers. ORMs simplify database interactions by letting you write queries in a syntax of your programming language of choice, instead of writing raw SQL. For SQL databases, popular ORMs are Prisma and Drizzle, or even SQLize. And for NoSQL like MongoDB, there's Mongoose. Here's how it would look like to fetch a user using Postgres, and here's how it looks like to fetch it by using Mongoose. These ORMs speed up the development and help you prevent errors, especially in larger projects. And remember those database courses that I mentioned not that long ago? Well, in those, I teach you how to use an ORM no matter which database you choose. So, if you want to learn how to use an ORM, definitely bookmark them and then revisit them after watching this course. But with that in mind, let's do a quick databases recap. Databases are specialized software for storing, organizing, and managing data. They come in two main types: relational, SQL, and non-relational, NoSQL. Relational databases use structured tables and SQL queries, while NoSQL offers flexibility with formats like documents and key-value pairs. And you can interact with both databases using either raw queries or simplify things using ORMs. That was a lot to comprehend, right? Don't worry, you don't have to get it at once. From understanding clients and servers to APIs, backend logic, and databases, there's a lot of moving parts. And if it feels overwhelming, don't worry. Take your time, revisit these concepts, and let them sink in. It's all a part of building a solid foundation as a backend developer. So, before we wrap up this course, there's one final piece to cover: backend architectures. Because how you design your backend is just as important as the tools you use. So, let's dive into that next. Now that we've covered how databases and APIs work, let's zoom out and talk about the big picture: how to structure your backend code. The backend architecture is all about the design and the structure of your app. It's not rocket science, but it is crucial for building scalable, maintainable systems. There are a few popular architectures that developers follow depending on their project's needs. So, let me break them down. The first and the most popular one is the monolithic architecture. In a monolithic architecture, all components of your application are combined into a single unified codebase. Makes sense, right? Everything's in one place. And therefore, the backend handles everything, from user management to business logic and database interactions. It's simple to develop and deploy, and it's easier to debug since everything's in one place. But it can get a bit messy if the app grows, and scaling specific parts of the app can be tricky. But as I said, it has been the go-to architecture for years, and it's exactly what I'll teach you how to build today. And the second type of backend architectures are microservices. In a microservices architecture, the application is broken down into smaller, independent services. Each service handles a specific business function, like authentication, payment, or notifications, all separated, and they communicate with each other via APIs. So no longer do you need just a single front-end and back-end connection through an API. Now every single part of the backend also needs to communicate through its own APIs. Making microservices great for large-scale applications or enterprise systems where flexibility and scalability are important. And then there's the serverless architecture that lets you write code without worrying about the underlying infrastructure. Your cloud provider, like AWS Lambda, and nowadays even Vercel, handles provisioning, scaling, and server management for you. So if you build a full-stack Next.js application, you've probably already worked with serverless backends without even realizing it. Serverless is perfect for startups, rapid prototyping, or apps with spiky traffic, because you can very easily increase the capacity that your server action can handle. And there are other architectures too, but these three are the most popular and most widely used today. So if you'd like me to cover microservices or serverless architecture in detail someday, just drop a comment below and let me know. All right, that's it for the theory. But before we dive into the hands-on part, let's take a moment to just appreciate what you've accomplished. We've covered a ton of ground, from how clients and servers communicate using protocols and APIs, the different types of APIs and how they structure data, to how to build and manage databases and interact with them using raw queries or ORMs. And finally, you learned about backend architectures and how to structure real-world applications. That's huge. So what's next? Well, now that you've mastered the fundamentals, it's time to put that knowledge to work. We're gonna build a subscription tracking API, a real-world project where you'll apply everything you've learned so far, from setting up a monolithic backend, using Node.js and Express, to connecting a MongoDB database, securing your API with ArcJet, and automating subscription tracking with Upstash workflows. If you were expecting a flashy, eye-catching UI, I hate to disappoint, but this video is all about JSON in action. So let me give you a quick demo of the API you'll build. We'll use an HTTP client called HTTPy to test our API endpoints. It's a tool I recently discovered as an alternative to Postman, and I've been really enjoying it. We have three main endpoints, one for users and one for subscriptions. And for each one of them, you'll create dedicated controllers, or in other words, logic that makes them work. So starting off, we have a regular root route endpoint. If you just make a GET request to localhost 5500, you can see welcome to the subscription tracker API. But now let's say that someone wants to spam our API and bring our server down. Well, I'll teach you how to stop them. Let's keep spamming our API. And if you do that for a couple of times, very soon you'll be hit with a rate limit exceeded. This means that you'll stop bad users from making additional requests and crashing your server. On top of that, we'll also implement a bot protection system that'll block them from accessing your API. All of that using ArcJet. Now, let's test another API endpoint so I can show you some of the functionalities. I'll make a post request to API v1 auth signup, and I'll send some user info as the request body. Now, if I click send, you can see that a new user has been created successfully. And the first thing we get back in the data is a JSON web token. So yeah, we'll implement that as well. Now, if you want to see your profile, you can make a GET request to API v1 users, and then you have to enter the user ID, which we got from here. So let me just do that and remove the body. And if I click send, and if you make a request, you'll get a 401 unauthorized, which means that we have a complete authorization system implemented. But now, if you copy the JWT that you got when creating your account and paste it right here as the bearer token and retry the request, we get back all the user info. You can also get a list of all the users just by going to API v1 users. But what matters most is creating new subscriptions. We can do that by targeting our API v1 subscriptions and then making a post request to it. And of course, we have to send the right request body, where we specify the name of the subscription, the price, the currency, frequency, start date, and the payment method, and let's create it. And in just a second, a new subscription has been created. And before we create this new subscription, we also have this special logic to auto-calculate the renewal date if it's missing. So what's happening behind the scenes is we take the start date, and then based on the frequency, we automatically calculate the renewal date. And don't get fooled here. If you pass any random values, let's say a random currency which doesn't exist, and try to create it, you'll immediately see a validation error, which means that you'll learn how to do full validation of your APIs. But maybe the most important thing is that as soon as you create your subscription, an automated workflow kicks in, sending you multiple email reminders a week before your renewal date. That way, you have plenty of time to decide whether you want to keep the subscription or cancel it. No surprises. Check this out. I just got an email that tells me exactly when my subscription renews, along with all of my details and the payment method. Pretty cool, right? And just like that, you'll receive the rest of the emails automatically for every subscription you create. It's a real-world solution to a common problem. No more stressing about remembering when to unsubscribe or manually setting your calendar reminders. Just enter your subscription details, sit back, and relax. By the time you finish building this amazing production-ready API, you'll have learned how to deploy, scale, and show it off to potential employers. So let's stop talking and start building. We'll first need to set up a couple of things to make all of this work. This will allow us to focus on coding without any distractions. First, let's set up Upstash, a serverless platform that allows us to implement Redis, scheduling, and workflows. For example, apps like Duolingo send automated emails to onboard new users and remind them to keep learning. That's an onboarding workflow. Subscription services like Netflix send reminders about payment renewals before the charge happens. That's a subscription workflow. And today, I'll teach you how to build something similar, a workflow that sends reminders about upcoming subscription payments. That way, you can cancel subscriptions early and save money instead of waiting until the last minute of the last hour of the last day, and you may end up paying eventually. This is just one of the use cases of what Upstash allows us to do. So let's quickly set it up. Click the link in the description to follow along and see exactly what I'm seeing, and then create a new account. Once you do that, we'll be able to grab all of the environment variables we need to make this work. We'll store them somewhere securely very soon. It's super simple to set up, and the implementation won't be any different. Now, the second thing we'll set up is called ArcJet. Once again, the link is in the description, so just click it to follow along, as it'll allow you to secure your whole application within a few lines of code in a few minutes. Remember that rate limiting or bot protection I was telling you about? We'll do it using ArcJet. So just sign up for free and create a new project. I called mine Subscription Tracker. And the last thing to set up is the hosting. For the first time ever, I'm gonna go against easy hosting services, and I'll teach you how to deploy your app on a Hostinger VPS. A virtual private server is like having your own computer on the cloud or some other physical location in the world, but without the high cost of a physical machine. You'll get dedicated resources, full control, and complete customization, allowing you to run applications just the way you want. And it's not just for hosting APIs. You can deploy full stack applications, run databases, train AI models, or set up game servers, automate tasks, or even experiment with new technologies without worrying it'll break your device. But why should you care? Hosting on a VPS might sound like an overkill, but it'll actually teach you real-world skills that companies expect of you. You'll get hands-on experience with server management, database backup, and real-world deployments. Skills that most tutorials skip because they're super hard, but also super needed. Also, unlike regular shared hosting, where millions of people host their apps on the same server, a VPS will give you much better performance because it's only made for you. So let's set it up. You know very well that I use Hostinger for all of my hosting needs. They recently launched VPS hosting for Node.js applications. So click the link in the description to be able to follow along and see exactly what I'm seeing. You'll get your own dedicated server with lots of RAM, SSD storage, worldwide data centers, and a Linux operating system, which we'll use to set up our server. And the best part? It costs less than a Udemy course, but having the knowledge of deploying your apps on there, priceless for potential employers. In our case, the one core plan is going to be more than enough. So click the link down in the description and select it, choose the period of your hosting, and enter a coupon code. Since you're a part of JSM, Hostinger is offering you an even bigger discount. Continue with the payment, and I'll see you on the inside. In your dashboard, you'll see some kind of an onboarding, and at the end of the day, you'll have your own machine running somewhere in the world. Don't go through the onboarding now, because we'll go through it together later on once we develop our app and once we're ready to host it. Okay, wasn't too difficult, right? Let me know in the comments if you'd like to set up things before getting started, like what we have done right now, or you prefer the usual process of setting up things in between. But for now, we have everything we need, so let's dive right into the code. To get started working on our amazing Subscription Tracker API, open up your desktop and create a new folder. You can call it something like Subscription-Tracker. Once you do that, open it up within your code editor of choice. Any editor is fine, but in this course, you'll see me use WebStorm. It's more than an editor, it's an IDE. And as of recently, it became completely free for non-commercial use. So once you're there, either open up a new dedicated terminal window, or you can use one built right into your editor or IDE. It'll look something like this. So let me show you how you can very quickly spin up a new Express application. We can do it by using something known as an Express generator. Simply run npx express-generator and add a no view flag, which will skip all the front-end stuff since we're focusing just on the backend. Also add a --git flag and the name of the app, which is /, meaning to create it in the current repo. And then press enter and continue. As soon as you do that, you'll see a couple of files and folders that were created for you. We'll start from scratch. So let's delete most of the stuff that we don't need. We can delete the bin, public, and the routes folders, and clean up the contents within the app, as we'll create everything from scratch. First things first, we'll need to install something known as nodemon. So let's run npm install --save-dev to save it as a dev dependency and say nodemon. What nodemon does is it always restarts your server whenever you make any changes in the code. I'll show you how it works very soon. To make it work though, we have to head over to our package.json, which was generated for us when we ran that Express generator. Within here, you can change the name of your app to something like subdub. It's a funny name that we chose for this entire API. And below private, above scripts, you can add something known as type of module. This will allow us not to use that old require syntax, but rather new ES6 import modules, but rather new ES6 plus imports. And we also have to change some scripts. First, we can have a start script, which will simply run node app.js. And we can also have a dev script, make sure to put it in double quoted strings, which will run the nodemon version of that same app. Let me show you the difference. If I now head over into the app.js and add a console log, server running, if I open up the terminal and run npm start, you'll see server running, but immediately after, it stops tracking it. So if I say server running on localhost 5000, nothing will happen. I would need to rerun it every time I make the change to be able to see this difference. But if I now run it by using the npm run dev command using nodemon, you'll see that now it's tracking it. And it says server running on localhost 5000, but if we change it to something like 3000, the changes will be automatically reflected in your terminal. Great. Now that we got that out of the way, let's also make our development process smoother by setting up a linter. A linter will allow us to keep our codebase clean, so we can add more code in a clean way as we continue scaling our API. We'll install the most popular linter called ESLint by running npx ESLint --init. It'll ask you a couple of questions, such as how would you like to use it? In this case, we're going to use it to check syntax and find problems. Next, what type of modules are we using? We're using the modern import-export. In this case, we're not using a framework, so I'm going to select none of these. Does your project use TypeScript? In this case, it's going to be no. If you want to follow along and try to implement TypeScript on your own, that's totally okay with me. But for simplicity's sake, so we can focus on what matters, I'll say no. Our code will run in Node, so follow the steps right here to toggle off the browser and turn on the node. It'll tell you that for this to work, you need to have a couple of dependencies. So say yes, install them right now using npm. And there we go. The dependencies have been installed. And right now we have a new eslint.config.js, which will make sure that we keep our code clean. Depending on which editor you're using, you might have to head over to ESLint settings and then turn it on manually by pointing it to that specific package. Same thing for the configuration file. And then we can run it on save. This will be a bit different for each editor, but don't worry about that too much. With that in mind, we have now prepared our code base so we can start creating our Express server. So let's do that next. To start creating our Express server, let's head into the app.js and let's make it work. We can do it by importing Express from Express. And then we are ready to initialize our app by saying const app is equal to Express. And then we call it as a function. As soon as you do that, you're already ready to create your first route. You can do that by referring to the app instance and then calling the method of the HTTP call you want to make. It can be app.post, app.put, or in this case, a simple app.get. Then the first parameter you pass into it is the path of where this route will be reachable. In this case, it'll be just /, meaning on the home page. And as the second parameter, you can pass a callback function, which typically looks something like this, an arrow function, where as arguments, you'll have access to the information about the request and the response. And you can put them to use within this callback function. What we typically do when we create a new API is just say rest.send hello world, or in this case, we can do something like welcome to the subscription tracker API. Even though you've created your first route, that's not enough to be able to access it. We have to make our server listen for requests trying to access specific routes. And you can do that by calling the app.listen method and specify on which port you want to listen. In this case, we can do something like port 3000. And then you can define a callback function, which will be executed once you run the application. And there you can just do a console log, say something generic like server running on port 3000, or you can say subscription tracker API is running on http://localhost:3000. This will expose the full URL of where you can access your routes. And don't forget to run export default app. With that in mind, let's give it a shot and run our application. I'll do it by running npm run dev. You can see that NodeMon has started and subscription tracker API is running on localhost 3000. You can click this URL right here, which will open it up in the browser, and you can see welcome to the subscription tracker API, which means that our server is active. Great. That's a good start. But in the next lesson, let's set up our environments so we can run this application both locally and in production. To start setting up different environments, we need to have different places where we can put and retrieve our environment variables from. So open up your terminal, stop your application from running by pressing Ctrl+C, and then run npm install.env. It's a package that will allow us to retrieve our environment variables. So create a new folder and call it config. And within config, create a new file called env.js. Within it, we can import config from the .env package, and then we can set it up and then giving it a path pointing to our .env file. So if we had just one, you could have said .env like this. This will then extract all the environment variables, and then you can export them from this file, such as the port we're on. Export const port is equal to process.env, meaning that it's coming from the environment variables file. But now here's the thing. We don't want to simply have one environment variables file. We want to have multiple for different environments. So let's actually make this a template string and say that it'll start with .env. But then it'll pull from environment variables the process.env.node.env, which is the node environment. Or if that doesn't exist, it'll default to development. And it'll also end with .local. Now let's fix this typo. Looks like I said node end. It was supposed to be node env as an environment. And let's create those two files in the root of the directory. The first one will be called the .env.production.local. And the second one will be called .env.development.local. Within the development local, let's add a comment. You can add comments by putting the #. And then on the new line, you can say port is 5500. This is a typical backend port. We don't have to define anything in production for now. We'll just keep it on development. So now we're accessing this port from our environment variables, and we can also access the node env if it exists. By default, it's set to development anyway. This way, we can very easily switch between production and development envs without overriding one another. All we have to do is change the node env right here in production to be equal to, well, you can guess it, production. And by default in the development, it's already set to development. Great. Now let's go into our app And let's use this port coming from the config. We can do that by importing port coming from ./config/env.js. And now, instead of manually saying 3000 right here, we can change it to port. And we can also turn this into a template string. So whenever the port changes, we can now say listening on port, and we can add port right here. If we now rerun our application by running npm run dev, you can see that we have the subscription tracker API running on localhost 5500, which means that it's successfully pulling the data from our development environment. And one thing you must not forget to do is head over into .getignore and scroll to the part where we're ignoring different .env environment variables, and you have to say .env.*.local, which will make sure to ignore all the env files and not push them to GitHub later on once we do push. You never want to share those with the internet. Great. In the next lesson, let's set up our routes. To make your API serve its purpose, typically you need routes or endpoints that do their job. That way, front-end apps or mobile apps, or really anyone that you allow, can hit those endpoints to get the desired data. So let's go ahead and create a couple of routes. We'll do it in a super organized way by first creating a new folder, which we'll call routes. Now, you could have totally had all your apps routes within a single app.js file, something like this. But of course, not all routes are just one-liners. They require more code and specialized logic. For that reason, we'll separate our routes based on their functionality. We can do it with separate files. I'll create a new file and name it auth.routes.js. This will be our first separate router. Let's import router with a capital R coming from Express, and then let's initialize it by saying const auth router is equal to router, which we call like this. Then, similar to how you did the app.get, now you can do auth router.get, or in this case, it'll be a post route to /sign-up. And then you already know it, you can define a callback function that'll be executed once you call that API route. In this case, I will simply return a string of sign up. But to return something from an API, it is not enough just to return it. You have to actually send it by using the res.send method and then pass over the text as body. And that response typically won't be just a single string. Usually, they're in a JSON format where you have something that looks like this: a JavaScript object with different properties right inside of it. In this case, I can render a title and it can be sign up. We can duplicate this one 2 times to create 2 other routes. The second one will be for sign in, and the title will say sign in. And the third one will be sign out, where we can say sign out. Of course, we haven't yet implemented actual functionalities for these routes. Right now, they're just returning a piece of text. But very soon, we can insert functions that are gonna deal with the logic of whatever that route is supposed to do right here. For now, we're just creating the structure. And at the end, you also have to export default that router. Perfect. These are auth routes. So now let's create another one. I'll create it for a user. User.routes.js. You know the drill. We import the router coming from Express. Then we instantiate it by saying const user router is equal to an instance of the router. And then you can define the user router and then different routes. For example, we can have a route that gets all users. That will look something like this: user router.get / we get the rec and the res, and then we simply return a response. In this case, we can have an immediate return, so we can do something like res.send, and we can give it a title, something like fetch all users. Or we can be consistent with our HTTP verbs, so this will be get all users, and we can duplicate it a couple more times. The second one will not get all the users, but it'll get the details of a singular user. So in this case, we're using this special colon and then ID property, which stands for dynamic parameter. So for example, you can have a static parameter / users, for example, which is always going to look like this. And whenever somebody hits it, they're going to get back all the users. But we also have dynamic parameters where it can look something like this. Get users 1, 2, 3, or something else. And every time it'll get different user details. Perfect. So in this case, we'll say get user details. The third one can be a post route under /. Oh, this one is also just a /. So keep in mind, you can have multiple routes with the same endpoint, but they have to be different HTTP verbs. So one can be get and the other one can be post. This one we'll use to create a new user. And I think they're too close together. So let's give them some space to breathe. We can also have another put route. Puts are typically used for updates. So we have to know which user to update. So I'll also specify the dynamic ID parameter. And this one will update the user by ID. So update user. And finally, the last one can be user router delete. And we also have to know which user to delete. So we'll also get that ID. And the title of that route will be delete a user. Perfect. Finally, let's export default that user router, and we'll be able to use them very soon within our app. Now that we know the drill, creating one more file will be super simple. Let's just call it subscription.routes.js. Once again, we'll import a new router coming from Express. We'll instantiate it by saying const subscription router is equal to the call of the router. And then we can define different routes by saying subscription router dot, and then we can define different endpoint as well as the handler. Let's start with just /. This one will res.send a title of get all subscriptions. So if we're being descriptive enough, we don't even have to add a comment of what exactly this one does. We can already know just by looking at it. And typically, if you're following well-written HTTP REST API guidelines, you'll always know exactly what which route does. If you Google for REST API naming conventions and best practices, you'll very quickly understand how it works. Make sure that your URLs are named with nouns to specify the resource instead of using verbs. So the URIs themselves shouldn't indicate any CRUD operations. You shouldn't say create items, get employees, update prices, and so on. You should do what we're doing in this video, where you're going to have users or subscriptions, and then you can either have a specific item ID, or you can just have / subscriptions and get all of them. Same thing here, use pluralized nouns for resources, like items or employees. That's bad. You always want to use plural, similar to what we're doing with users or subscriptions. Use hyphens to connect different words together, and so on and so forth. And so on. But I'm already teaching you all of those practices, so you don't really have to think about them. Just learn how to do things properly. Oh, and you might wonder, like, not that long ago, we already had a user route that was a get route that started with a /. But here we have a subscription route, which can also be .get and also the /. So wouldn't those routes clash? Well, not really. Let me show you why. I will export default this subscription router so we can use it within the app. As a matter of fact, we'll import all of these routes right within our app.js. You don't have to explicitly code them within here, but they definitely have to be imported here because the app is the center of your application. So let's import the user router coming from /routes / user.routes.js. And let's also duplicate it 2 times and import the second router, which is the auth router coming from routes auth routes.js. And finally, we have a subscription router, which is coming from routes subscription.routes.js. Once you import them, you have to put them to use. Right here below the app, we can say app.use. And we typically use the use keyword with something like middleware, where you want to maybe tell your application that it's going to be using JSON. But we also use when you want to say which routes you want to use. So in this case, we can say app.use /API /v1 /auth. And then here we can render the auth router. This means that you can get to this signup by first heading over to /API /v1 /auth and then sign up like this. Hopefully that makes sense. So you're prepending whatever is here, and then you're attaching these additional routes to it. In a similar way, we can add the users. Keep in mind, good practice to keep it plural. And then we can also add the subscriptions. This is going to be the user router. And finally, we're going to have the subscription router. And the answer is that these two don't clash because this is API v1 users and this one is API v1 subscriptions. Perfect. Now let's finalize our subscription routes and then we'll be able to make calls to our API so I can show you how that works. For now, I'll duplicate it a couple of times and create some space just so we can see what's happening. The second one will get subscription by ID. So it'll still be get, but it'll have a colon ID right here and it'll be get subscription details. The third one can be a post, which we'll use to create a subscription. So this will be a create subscription. After that, we also need to update the subscription. So we'll say put based on a specific ID, update a subscription. After that, we need to be able to delete a subscription. We're basically dealing with CRUD functionalities right here, a foundational element of every single API out there. You need to be able to delete, create, or read, or update literally anything out there. And on top of all of these basic CRUD operations, we'll also need to get all the subscriptions belonging to a specific user. So we can make it something like /user / and then ID. That way, we can try to extract all the subscriptions of a specific user. So get all user subscriptions. We'll also have another put right here below, which will cancel a user subscription. So this one will go to /:ID /cancel, and we'll call it cancel subscription. And finally, we'll create one more route, which will get us all upcoming renewals. That way, we can know which subscriptions are coming soon. So I'll say get upcoming renewals. Perfect. This seems like a lot of routes, but they're nicely contained within their own file, and we're importing them here so we can actually use them. So what do you say that we put it to the test? Our application is running on localhost 5500. So if you open it up, you'll see that it works. And if we try to maybe get all subscriptions, that's going to be under API v1 subscriptions. So we can append that to localhost 5000 URL. And you can see that my browser automatically turns this into a JSON format. And we even have this nice pretty print option, which returns it in a nicer format. Title, get all subscriptions. If we had to v1 users, you can get all users. But these JSON outputs are never meant to be read by a user on a site. I mean, sure, you can make GET requests using the browser because when searching for a website, a browser automatically makes a GET request and outputs the HTML for you. In this case, that response is JSON data. But to test other types of HTTP requests, you'll need an HTTP client like Postman or Insomnia, or even modern lightweight HTTP clients like HTTPy, which has a very simplistic interface, but still gets the job done. And there's also another one which I found to be very popular, which is called simply Bruno, allowing you to make all sorts of different HTTP requests. Nowadays, there's also HTTP clients built right into your editor. So just Google the name of your editor and try to find a package that does that for you. I really needed something simple, and HTTPy delivered. It's just a free download. I installed it on my device, and now I can make GET requests similar to what my browser can do, but I can also very easily switch it to a POST request, for example. And if I try it, you can see that we get a title of Create Subscription, which means that we have now successfully hit not only our GET routes, but also the create routes. We know that because we got this JSON back right from our API, create subscription. In the next lesson, let's set up our database, which will make us one step closer to implementing real functionality to store and retrieve subscriptions. Now is the time to set up our database. You could use something older like Postgres, or maybe something modern like Neon, which is a serverless platform that allows you to host Postgres databases online. Then you could hook it up with an ORM like Drizzle, and it would all work. But in this course, I'll use MongoDB Atlas, allowing us to very easily create our database and host it on the cloud, completely for free. Now, it is important to mention that up to this point, this course was completely database agnostic, which means that the concepts we learned could be applicable to any database. And if you wanted to use SQL, that's totally okay. I would still say follow through with the video, watch me implement MongoDB in a non-SQL database, see how it all works, and then later try to modify it on your own and switch it to an SQL database. You'll learn so much more that way. Or maybe in the future, I split this video in two and build it with other databases in mind as well. Who knows? But for the time being, head over to MongoDB Atlas and click Try Free. Create your account, and once you're in the dashboard, create a new project. Name it something like Subscription Tracker. Click Next. Make yourself the project owner, and when you click Create, it'll take some time. And then you'll have to create your database cluster, basically your database. Click Create and choose M0, which is the free version, which gives you about half a gigabyte of storage. And trust me, that is more than enough for storing JSON information. The rest of the option is okay, so just click Create Deployment. Now, this is very important. You can choose your username. I'll do JSM right here. And then you'll also have to choose your password. Make sure to write this password down as you'll need to use it later on within the code. Click Create and choose a connection method. In this case, we'll connect through a MongoDB driver like Node.js. So choose the first option and copy the installation command. npm install MongoDB. Back in the code, you can open up a new terminal and run npm install MongoDB. And let's also install Mongoose, which is an ORM for MongoDB, allowing you to more easily create your database models and schemas, and press enter. While that is installing, let's wait for a cluster to provision. Basically means your database is setting up. We can go back and then click drivers one more time to see if it's provisioned. If not, let's give it a minute. Once that is done, you'll be given your connection string, which you can copy and add to your codebase. But make sure to replace the DB password with the original password for your username. So back into the code, let me head over to our env development local and add new environment variables for our database. I'll call it db URI and simply paste the string that I just copied right here. MongoDB, SRV, JSM, and for my password, I chose just JSM as well. Hopefully you chose something more secure. Now we can head over into config envs, and we can also export const the db URI right here. Once you've done that, create a new folder, which we can call database. And within it, create a new file called mongodb.js. Within it, we can import Mongoose coming from Mongoose. And we can import the environment variables which we need. So that's going to be the db URI as well as node env coming from /config/env.js. We can first check if there is no db URI, then we can throw a new error. Something like throw new error, please define the MongoDB URI environment variable inside .env.local. And of course, this is .env. Either development or production local. So I'll make it super specific just so we know that it has to be .env. And then development production .local. If we pass that if statement, that means that we are ready to connect. So let's say const connect to database, and that'll be equal to an asynchronous function, which has a try and a catch block. In the catch, we get an error, and obviously something went wrong. So let's simply console log that error, saying error connecting to database, show that error, and then exit the process with a code of 1, which means failure. But we're trying to make something go right, and that something is await mongoose.connect. And we simply want to connect to this specific DB URI, which we got from MongoDB Atlas. And I believe that's it. We don't have to pass anything else. Now we have to call this function from somewhere. So let's export it by saying export default connect to database. And let's head over into the app.js. Where do you think we'll call it? Well, right here within app.listen, as soon as we start our application on localhost something, we can also try to connect to database. Make sure to import this function from the top. Await it, because it is an asynchronous function, and therefore you have to make this one asynchronous as well. If you've done that correctly, and if you head over into connect to MongoDB, alongside this await, once we pass it, we can also console log something. Maybe something like console logged connected to database in node env mode. So this is going to be either production or development. So now if you open up your terminal, you can see subscription tracker API running on connected to database in undefined mode. Oh, that's definitely not good, but I think I know why that is. We have only defined it in production, but I'll also add it to development right here under environment, and I'll say node env is equal to development. If I do it like that, make a change to any file and save, it'll say connected to database in development mode, which is exactly what we wanted. Great. Now that we have the routes and the database, let's go ahead and create some models. Models in our application let us know how our data is going to look like. So let's define it right here in the root of our application by creating a new folder, and let's call it models. And to keep everything organized, we'll create multiple files such as user.model.js, as well as a subscription.model.js. I think you can already start seeing the practice we have. We create separate routes, separate models, and soon enough, separate controllers for every one of these parts of our API. Once you understand the gist of it, you'll know how it all works. So let me show you how to create that model. We can first import mongoose coming from mongoose, and then we can define a user schema. Const user schema is equal to new mongoose.schema, to which you can pass an object that allows you to define how a specific model is going to look like. We can give each user a name and then make it an object to define more information about that name. For example, it'll be of a type string, and alongside required, we'll also pass an array and say true, but we can also define an error message if it's not there by saying something like username is required. That way, if something goes wrong in the code, we'll know why it is wrong, because we're missing a username. We can also trim it by saying trim true if we have some empty spaces in there, and we can give it a min length of something like 2 characters and a max length of about 50. What else does the user need? Well, we can have an email right here, and it'll be very similar with a type of string, required to true, user email is required. Unique in this case will be set to true because only one user can have that specific email. With a trim to true, we can also make lowercase to be true as well because email tend to be lowercase. And bear with me, I'll also show you how to write a very quick regular expression to check for emails. We can say that this specific parameter has to match the following format. As you can see, my copilot wrote it for me here. Nobody writes regular expressions by hand today. It's just a /, /, s plus, @ backwards, s plus, whatever it is. Basically, it means that we'll start with a string, followed by an @, some more string signs for the domain, followed by a dot, and then some more characters for the domain name extension. Something like contact@jsmastery.pro. Great. And finally, a user also has to, of course, have a password, which will be of a type string. Required will be set to true, and we'll say that the user password is required. We won't be trimming or messing with the password in any way, but I will set a min length to about 6 characters. Finally, we'll go a bit down, not below the password, but outside of the schema definition, and I'll set timestamps to true, which means that alongside these properties, we'll also have created at and updated at fields, so we know when that user has been created or modified. Perfect. With that in mind, we can create a new model off of that schema by saying const user is equal to mongoose.model with the name of user, and then we pass over the user schema we want to create that model off of. Models typically start with a capital letter. And don't forget to export default.model, off of which we'll then be able to create instances of that model, such as different users. So we can have a user that's going to look something like this. It'll of course have a name of John Doe, email, I guess, of johnny@email.com, and finally a password of password. We'll get to there by using the user.create method. We'll get to there by doing something like user.create and then passing over the information. But more on that later. For now, it's important that we have this model. Now that we know the basis of creating MongoDB models, let's create one for the subscription. Just to recap, our subscription will have a bit more fields as it's the primary part of our application, the main model, schema, and document. So let's import Mongoose from Mongoose, and let's define our schema by saying const subscription schema is equal to new Mongoose schema. I'll also immediately add the timestamps is true at the bottom, and now we can give it all sorts of different fields. I'll start by giving it a name, which will be of a type string. Required will be set to true, and I'll say subscription name is required. I'll also trim it, and I'll give it a min length of about 2 and a max length of about 100. After the subscription name, which can be something like Netflix, we'll have to have a price of that subscription. This one will be of a type is number, and it'll also have a required property to true, set to subscription price is required, with a min value of 0. And we can also add kind of like a message, price must be greater than 0. After that, we can define the currency that it is in. This is totally optional because you might be using just a single currency, but in case you want to add it, you can make it of a type string. But then a cool thing is that you can define it as an enum of one of these properties, like USD, euros, British pounds, or so on. You can add your currency right here. And then when trying to create a new subscription, it'll ask you for the currency as well. I'll make it default to USD. Another very important part of our subscription is the frequency. How often are you getting charged for that subscription? And this will be of a type string, and this will be an enum of daily, weekly, monthly, or yearly. We can also have a category for that subscription, just so we know where we're spending the most. And it'll be of a type is string. And we can also make it an enum of something like sports, news, entertainment, lifestyle, technology, finance, whatever it is, right? You get the idea. And I'll make this one required, set to true. Let's also define a payment method, which will be of a type string, required to true, and trim to true as well. And let's define a status of that subscription, which will be of a type string. It'll be an enum of either active or canceled or expired. And the default will be set to active. Now that we have all of these base properties, we also might want to know when is the start date of that subscription. So I'll say start date will be of a type date. It'll be set to required to true. And we can also validate it by saying validate, to which you can pass an object where you can define a validator function. So that'll look something like this. you can define a new callback function where you get the value, and then you can check if value is lower than or equal to new date, which is basically the current date. And if that is the case, you can provide a message, something like start date must be in the past, because you cannot create subscriptions in the future. And we can duplicate this entire start date, but this time I'll call it renewal date. Type of date required to true, and we'll validate it, but I'll switch it around. The value must be greater than the start date. And a pretty cool thing is we're not comparing it with date.now, we're comparing it with this dot start date. This, of course, referring to our model. And I'm not sure whether arrow functions will work with this. We might actually need to wrap it in an actual function. So we can say validator is a function. No arrow signs right here. Rather, it's a good old function where you open up a function block and then you can return this value. Perfect. And we can say something along the lines of renewal date must be after the start date. And the last missing piece of the puzzle is the user that actually subscribed to that subscription. So we can say user, and it'll be of a type mongoose.schema.types.objectID. So we're actually accepting the ID, which is going to be a reference to the user model that we have already created right here. We only need to get its ID. Required will be set to true, and we'll also set index to true, which will optimize the queries by indexing the user field. Don't get me wrong, if this is your first API that you're creating, well, this definitely is a larger model. It has a lot of interesting stuff right here, from strings to numbers to enums, some with default values, others with required values, and even some more specific properties where we're trying to validate the value that's being passed in by using the validator function. We're not keeping it super simple. I gotta keep you on your toes so you're always learning something. And then we also have references pointing to other models in the database. Now we'll improve it just a tiny bit more by creating a function that'll happen before each one of the documents is created. It looks something like this. Subscription schema dot pre, and we'll run it pre-save. So this next function, where you get the next as an argument, will be called before we save that document. Oh, and we're using the function keyword right here, so we don't need the arrow sign. What this function will do is it'll auto-calculate the renewal date if missing. So if we don't provide the renewal date, therefore we don't have to make it required, it should auto-calculate it based on the start date and the renewal period. So we can say if no, this dot renewal date. In that case, we can define different renewal periods, like const renewal periods is equal to an object, where daily will be set to 1, weekly to 7, monthly to 30, and yearly to 365. Then we can set up the renewal date to look something like this. This dot renewal date is equal to new date from start date. So now we have just made it a start date, but now we have to actually increase it by saying this dot renewal date dot set date, it'll be equal to this dot renewal date dot get date plus renewal period of this dot frequency. Might be a bit confusing, but basically what we're doing is we're adding this number of days based on the frequency that we pass in. So for example, if we started it on January 1st and the frequency is something like monthly, in that case, it'll be 30 days, which will end up being January 31st. Make sense? Hopefully so. We can go outside of this if, and we can also auto-update the status if renewal date has passed. So that'll look something like this. If this dot renewal date is lower than new date, which is the current date, then we simply set the this dot status to expired. After we do everything, we can simply call next and make it proceed with the creation of that document in the database. So in this case, you not only learned how to create a model that has all sorts of different properties, you also learn how to validate those properties before they're entered, and you learn how you can call specific actions before a document is saved, perform additional logic, and then modify, delete, or update properties on that instance based on external criteria, the lack of some properties like the renewal date, and so on. Perfect. Finally, let's create a model out of that schema, and let's export it. With that, we're done with the two primary models, the user model and the subscription model. And as soon as we authenticate our user, we'll be able to put it to the test where we'll be able to attach different subscriptions to different users. Before we do that though, let's improve the global error handling of our application, because as it's growing, we might start to make some mistakes in our code. So it's nice to have a centralized error handling system to track all of those errors. Let's create a global error handling middleware that'll nicely alert us whenever something goes wrong. We can do that easily by creating a new folder called middlewares, and within it, we can create a new file called error.middleware.js. And within it, we can define it just as a regular JavaScript function. Const error middleware is equal to a function that looks like this. Now, not just error middleware, but any kind of middleware in Node.js or any other backend software typically looks like this. Alongside the request and the response, you get two additional things: the information that happened before the request, and then what happens after, when you're ready to proceed to the next step. Let me explain what I mean by this. Like, let's say that we have the ability to create a new user. In a way, when we had a subscription model in the previous lesson, this subscription schema.pre was actually in a way a middleware, because it happened before something and then told us, hey, now we're ready to move to the next step. So let's say that you're trying to create a subscription. Then we have a new middleware that maybe checks something like check for renewal date. And then you can have as many middlewares as you want. We can have another middleware, maybe this one will actually check for errors. And then only when both of these middlewares call their next status, we are actually navigated over to the controller, which handles the actual logic of creating a subscription. Hopefully that makes sense. Basically, some blocks of code that are executed before or after something, allowing us to intercept what is happening. So let's open up a try and catch block. And in the catch, we get the error, and we'll simply send that error over to the next step to let us know that the error actually happened. But in the try block, we'll actually try to decipher that error to let us know exactly what the issue is. So I'll say let error is equal to, and I'll create a new object and destructure the error that we're getting through props. Then I'll set the error message to be equal to err.message, and I'll console log the error to the dev. So console.error, and then we pass the error right here, just so we know what's happening. After that, we can try to figure out a type of error. Maybe it is a Mongoose bad object ID. This is a very common error that we get when working with Mongoose and MongoDB. This one would happen if we have a cast error, if that is the name. So if that is the name, we can create a new message. Const message is equal to resource not found. And then we can set the error to be equal to new error, and we can pass this message right in. We can also set the status code to 404, so we know exactly what happened. Resource not found. Another type of error is a Mongoose duplicate key. That is when we're trying to create something with the same key, and this one happens if the error code is 11,000. Don't ask me how I know that. I've encountered this error one too many times. So if that is the case, we can again form a message equal to something like duplicate field value entered, and we can set that error to be equal to new error message and the status code of 400. Another type of common error is a Mongoose validation error. So when we're trying to create a document and we don't pass all the right props, so we can check if error.name is equal to validation error. In this case, we'll form the message by mapping over the values of the object, because we might have many validation errors, and we'll show a message for each one. Once we do that, we can simply set that message to the error and join it based on commas and spaces. So for each one of these validation errors, we'll add it to the error message. And finally, we can return the response from this error middleware by saying res.status is equal to the error.status code. It can be either 404 or 400, or if it doesn't exist, we can make it 500, which is a general server error, and we can return a JSON of success is false, as well as an error equal to error.message, or just a string of server error. So in simple words, what we're doing here is we're intercepting the error and trying to find a bit more information about it so we much more quickly know what went wrong. Now we can export that error middleware by saying export default error middleware, and we can use it within the app. So head over to app.js, and then let's add it right here below the routes. That'll be app.use, and you can call it error middleware, and make sure to import it from errormiddleware.js. Alongside this custom piece of middleware that we created, Express also has many built-in middlewares that we can use. Let's actually add them right here at the top. The first one you can see auto-recommended to me is app.use express.json. This allows your app to handle JSON data sent in requests or API calls, something that is super common. Another one is app.use express.url encoded extended is set to false. This helps us to process the form data sent via HTML forms in a simple format. And another one you'll often see used is app.use, and that is cookie parser. This one has to be imported at the top, so make sure to say import cookie parser coming from cookie-parser. This one, as the name says, reads cookies from incoming requests so your app can store user data. If you want to see how all of these works, you can just click into them and immediately see the code. And since this is the middleware, you know what it has to have. It has to modify the request, right? Do something with it. There's a reason why we had to have it in the first place. Intercepted it, did something with the request, modified it, and then, check this out, we're calling the next function, letting the request pass through. And it's similar with all the other middlewares. Later on, once we start working with our database, we'll make one or two of these rookie mistakes, and we'll get a very nice error message saying resource not found, or duplicate field value entered, or maybe a validation error. Either way, creating this global error handling middleware will save us hours of debugging later on, and it'll make our app that much more scalable. Great work. Now that we have our models, database setup, and error handling middleware, we are ready to dive into setting up our auth. We can do that by opening up a new terminal and installing some packages. We can run npm install JSON web token. Yep, we'll implement a completely custom authentication using JWTs. And we can also add bcrypt.js, which allow us to generate randomized strings to hash our passwords. Press enter and head over into our env.development.local. Let's create a new comment called JWT auth, and let's create two new environment variables, JWT secret. This is your string of characters that has to be specific, based off of which you'll be able to generate that randomized string. For now, I'll simply say secret. You can do the same too, or enter any kind of random characters. And we can also define when our JWT will expire. So we can say JWT expires in, and you can set it to any kind of number of days or minutes or hours. In my case, I'll set it to 1 day. Let's not forget to head over to our env config and to export those variables. So right here, we can put this into multiple lines, and we can export the JWT secret as well as JWT expires in. And with that in mind, we can create our first controller. So what is a controller? Well, let me create it and show you. Hopefully, it'll all start making sense given the clean code base that we have. I'll create a new folder called controllers. And within controllers, I'll create a new file called auth.controller.js. And within it, we'll create a new function and we can immediately export it. So export const sign up. And it'll be equal to an async function where we get the request, the response, and potentially the next as well. And here we can implement the sign up logic. So this is a dedicated space allowing us to focus explicitly on the logic of what these functions are supposed to be doing. We can create another one for sign in, which will look like this, and the last one for sign out. Very soon, we'll add the logic right here. But the question is, where are these going to be used? I mean, remember, we already have the auth routes, and we're going to now merge the two together. Auth routes before handled the logic on their own. And sure, this is okay if they're all single liners, but this logic can very, very quickly get very, very complicated, where we have multiple lines of information and hundreds of lines of logic for each one of these functions. You can get lost, and at the end of the day, you'll have no idea what different types of routes you have, and this file is all about routes anyway. So with that in mind, instead of defining the handlers right here, we can define the controller in a separate file and then import it into here by saying, when you make a post request to the auth router sign up, simply do the logic of sign up. And that logic will be coming from import sign up from controllers auth.controller.js. And now we made that connection or the bridge from the auth controller to the auth routes. Basically, the routes are just the endpoints that you can hit, and the controllers form the logic of what happens once you hit those routes. So let's also exchange it for the other two. In this case, we have sign in as well as sign out. We're already exporting them from there, so let's just make sure to import them, sign in, and sign out. And with that, we have a very clean routes file. So at any point in time, you know which endpoints you can hit. If you want to, you can even make a comment of something like path API v1 auth sign up. Why this? Because in the app, we're actually starting it with API v1 auth. And then in this case, it also has a sign up. And this is basically a post route. You can also write a comment like this for every single one of these routes, but again, might not be necessary because we're writing your code in a clean way, so it's self-explanatory. With that in mind, let's head into our controller and let's write our first controller of the day, the controller for the signup function. I'll do it by opening up a new function block and I'll create a new session by saying const session is equal to await mongoose.start session. Now, what does this do? Well, first of all, we have to import mongoose right at the top by saying import mongoose from mongoose. And this session has nothing to do with the user session. Rather, it's a session of a mongoose transaction. What does that mean? Well, here we'll run the session.start transaction. And we do this because we want to perform something known as atomic updates, also known as atomic operations. I found a random photo on Google explaining it. But basically, database operations have to be atomic, which means that they either have to do all or nothing. Insert either works completely or it doesn't. Update either works completely or it doesn't. You never get half of the operation. So if you start authenticating the user, but somewhere down the line, database fails and it doesn't fully add all of its fields, if you still add it to the database unfinished, you'll get a lot of errors later on. But if you notice that something went wrong and stop the operation immediately, then you won't have any issues and you'll immediately know that something wrong happened. That's exactly what we'll do here. This is a bit advanced, but bear with me. We'll open up a try and catch block. And as I said, if something went wrong, we can immediately await session.abort transaction session end session, and just call the next with that error. This means if at any point something goes wrong, don't do anything, abort that transaction. But here we can actually try to insert a new user, and then at the end, we will commit that session, which means that we are ready to commit to all of the actions we have done above. Hopefully it makes sense. I'll try to explain it as we go. Basically, the goal of this function is to create a new user. So let's get the data needed to know which user we want to create. In backend APIs, you typically get all of that information through a request body. So what is a request body? Let's explain it. What is a request body? A request body is an object containing the data coming from the client, specifically when you have a post request. Why am I mentioning the post? Well, because if you check the routes right here, you'll notice that the sign up functionality is indeed a post route. And opposed to just a GET request where you simply make a call and that's it, on the post request, you're also allowed to pass some data. In this case, that data will of course be something like the username or email or password. So we can destructure the passed values from the front end right here. Const name, email, and password is equal to request.body. After that, we can check if a user already exists. We can do that by saying const existing user. And here we'll make our first database call by using Mongoose and saying await user. Keep in mind, this user is referring to the user model that we created not that long ago. And we'll say user.find1, where the email is the same as the one that the user is trying to create a new user account with. Then if an existing user already exists, in that case, we can create a new error by making it equal to new error, user already exists, and we can set the status code to 409 and throw that error. This typically means already exists. If it doesn't exist, we can hash the password for the new user. Hashing a password means securing it because you never want to store passwords in plain text. So how does it work? Well, first, you need to get access to something known as salt, which is like a complexity you want to use for randomizing your hashed password. So let's say salt is equal to await bcrypt.gensalt. So this is a method, and typically the default number is 10. Make sure to import bcrypt coming from bcrypt right here. That's bcrypt.js. Once we have the salt, we can get the hashed password by saying const hashed password is equal to await bcrypt.hash. You pass the plain text password from the user and the salt you generated right above. Once you have it, we are ready to create a new user by saying const new user is equal to await user.create. And now you can pass an array of how many new users you want to create alongside with their info. For now, we only want to create a single user. So I'll pass their name equal to name, email equal to email, and password equal to hashed password. Now, something could go wrong when creating this user. So that's why we want to also attach a session to it, which means that if something goes wrong, and if we later on abort that transaction, then the user will not be created. But if you reach the end of the try block, means we're good, and we'll actually commit the transaction, which will create the user. Finally, let's generate a token for the user so they can sign in. Const token is equal to JWT. We have to import JWT at the top, coming from JSON Web Token. And we can say JWT dot sign, which will take in an object of user ID is equal to new user 0 dot underscore ID. We're calling 0 right here because when you pass an array of documents you create, it will return the array of new users. So maybe it's going to be better to call this new users, and then we get the first and only one which we create and get their ID. And as the second parameter, you have to pass the JWT secret. And as the third parameter, you can pass an object with additional options, such as expires in, and you could manually type it, but we already created a JWT expires in environment variable. Hopefully this makes sense. We are attaching a JSON Web Token to the user with the following ID. Once you do that, we are ready to commit the transaction, end the session, and finally return the res.status of 201, which means created, .json, and we can return the success is equal to true, message is equal to user created successfully, and we can pass the data, such as the token, as well as user, which is equal to new users 0. This is the function to create a new user. So let's go ahead and collapse it. And we're already exporting it and using it right here under our auth routes. So as soon as somebody hits this endpoint, this function will be executed. So let's test it together. You could either watch me do it, or you could download one of these HTTP clients and test it on your own. So we have to head over to API v1 auth and then make a post request, but we also have to pass a body. And this body will be in form of a JSON. So I'll create a new object. And remember, now we have to specify these three things, which our code will then accept: the name, email, and password. So for the name, I'll do something like Adrian JS Mastery, and we're working within JSON. So make sure to wrap everything in double quoted strings. The email will be something like contact@jsmastery.pro. And finally, the password can be something like 123123. Perfect. The body seems to be good, and we are ready to make a request. This time, instead of getting simply the title of create subscription, we should get back whatever this function is returning: a 201 with a success true, a message, and the data of the newly created user. So let's give it a spin. I'll click send, and we get a 404. Oh, that's because I just hit auth. But in this case, if you take a look at our path, it actually has a /sign up as well. So we can differentiate it from sign in and sign out. So if I append sign up to it and click send, you can see false, user is not defined. Okay, this is good in a way, because at least we got some meaningful information right here. See, success is false, and then we get the error message. If that sounds familiar, it could be coming from error middleware, where we actually return a success of false and then a meaningful error message if it comes to it. And in this case, the error message is user is not found. So this is helpful to us. If we now search for user, you can see that I'm mentioning it a couple of times because this is all about users. But I think the one that we should be concerned with is this one right here, where we're trying to create a new user. You don't create it with a lowercase user in mind. You create it based off of the user model, which starts with a capital U. It's this model we created based off of all of these properties. So now that I fixed this typo, I'm actually glad it happened because we got a chance to explore how to handle errors. I'm ready to send another request. So I'll click send. And this time we got yet another error saying JWT secret is not defined. This time it's referring to this one right here. And if you can see, I forgot to import it from our envs. So let's get it right here. Save the file and send it once again. This time we get a 201 created. You can see all the information about the request that is being made, success true, message user created successfully, and the data with the user's token, as well as their name, email, and a hashed password. Would you look at that? We also got a user ID and created that and updated that fields. Now, what I would recommend is saving this user token as we might need it for future requests. So maybe add it, I don't know, let's add it to our env development just so we know. And I'll add a comment of token and paste it right here. And we can also add another one for the underscore ID. So if we need to get the ID of our user very quickly, we can always grab it from this file. Great. And since we got a 201, that must mean that the user was indeed created in the database. So if we head over to our clusters and click on cluster 0, head over to collections, you should be able to see users, and you can see a new user created in the database. That means that our first post API call succeeded and it talked to the database and created a new user. Now, if you have any issues with MongoDB, you might need to head over to network access and add an IP address and click allow access from anywhere. Sometimes it stops some IP addresses, so you cannot make changes. So if you do this, it'll just work for all IPs. Great. Now let's head back to the code to auth controllers and let's create the sign in function, which will allow us to sign our user in. I'll do it right here. And first I will open up a try and catch block. In the catch, I'll simply get the error and forward it over to our error handling middleware. But in the try, I'll try to destructure this time just the email and the password from the body. No need to get the name because we're already signing in to our account. Then we'll check if a user exists by saying const user is equal to await user.find1 with a specific email. And by the way, if you're wondering how this filter thing popped up right here, that is something that WebStorm IDE adds. It automatically recognizes what this find1 method wants as the first parameter, and it tells us what that is. Next, if a user doesn't exist, we can throw a new error, something like user not found 404. But if it does exist, we can try to validate their password by saying const is password valid. And we'll do it by using await bcrypt, coming from bcrypt.js, dot compare. We want to compare the new password that they entered with the user password stored in the database. Of course, bcrypt will actually hash this new password that you're typing and compare it with the hashed password in the database. I'll just spell it properly. That is compare, and make sure to import bcrypt from the top. Next, if it's not valid, so if password is not valid, we can throw another error saying new error invalid password with a 401, which means unauthorized. But if it is valid, we can generate a new token, which will be similar to what we had before. jwt.sign user ID is equal to user._ID. This time we don't have to destructure the first element from it because we're not adding that session transaction, because this is just a sign in, not a sign up. So we're not creating anything. We pass over the JWT secret and the expires in functionality. Once we do that, we are ready to return a res.status of 200, which means successful. And as a JSON object, we'll pass success true, user signed in successfully, and we will return the data of the token and the user. Great. So now we have the functionality to sign our users in as well. Let's make sure that we have actually passed it as a controller to the sign in route, and we can actually test it out. If I now go over to sign in and I remove my name because we don't need it, but I do need the correct email and password, we should be able to sign in successfully. So I'll click send, and you can see user signed in successfully, and we get a new token if needed. Beautiful. If you try to sign in with an invalid password, like something like 123456, you can see invalid password. Or if you try to sign in with an email that doesn't exist, maybe you make a typo, you'll see user not found. Beautiful. Complete error handling. So if you now had a beautiful front-end application, you would be able to nicely show these errors on the front end, allowing your users to see what they did wrong. We're using this HTTP client to mock what the user would be seeing on the front end. But basically, this would be a form. And what does that form do? Well, it basically calls our API. That's how it goes. You make a nice form on the front end, and you make a call to API v1 auth sign up, and you pass all the post request details, like the post body, such as the name, email, and password, and it creates a new user. Make sense? Hopefully it does. And with that, we're ready to move to the second part of creating our users, and that is authorization. Once we've created our users, we need to be able to authorize them, meaning make a GET call to the database to figure out which users are in there. To authorize our users, let's create a new file right here within the controllers folder, and let's call it user.controller.js. Within here, we can import the user model coming from /models user.model.js, and we can define two functions. The first one will fetch all users. So we can say export const get users is equal to an asynchronous function, which accepts the request and the response as the params, and we can open up a try and catch block. In the catch, we get the error, and we can simply forward it over to our error handling by saying next error, and that next is coming as the third parameter right here into this function. But when it comes to what we'll actually try to do in this function, we can try to fetch the users by saying const users is equal to await user.find, and we'll simply find all the users like this. Next, we can say res.status.200, and in the JSON, we can simply return a success is equal to true, as well as data is equal to users. And this is it. This is a function that fetches all the users from the database. We can duplicate it below and rename it to get user, which will get a singular user. In this case, we'll say user is equal to user.findById, and to it, we can pass the rec.params.id, and then also call the .select, where we're gonna select all the fields minus the password. We just want to get the user info, but we don't care about the password. We only care about that when logging in. Finally, if there is no user that we're trying to fetch, we can create a new error by saying const error is equal to new error, and we can say user not found. We can also set the error.status code to 404 and throw it. That way, we'll be able to catch it right within our error handling middleware. Else, we'll simply say res.status200, JSON, success true, and data is equal to user, singular user now. Great. So now let's put those two to use by heading over into our routes, specifically user routes. We have a route that fetches all the users, so I can simply do it right here. I'll call the get users. There we go. And then right below it, we have another one which fetches the users based on its ID. So here we can call the get user, and make sure to import both of these coming from controllers, user.controller.js. And this is a pretty cool thing. See how we have this dynamic parameter of ID. Now, how are we fetching it in the get user? Well, it's getting to us through rec.params ID. You know how through the post requests, we can pass a request body, but through get requests, we can also pass the data through the request parameters. So in this case, since it's called the ID, we can extract that ID value right from rec.params ID. Now, let's go ahead and test it out. I'll open up our HTTP client, and we'll want to target the API v1 and then users endpoint. And this time, we're making a GET request. If you do this and click send, you'll be able to see create new user. Oh, looks like it didn't switch the request. So if you do it one more time and click send, now you can see the only user that we created with our name, email, and password. Now, what we could do is maybe prevent regular users from making this call because it could expose all the users in the database. I'll show you how to do that very soon. But for now, let's grab this user's ID and let's make a request to the same URL, but append that ID right at the end and make a request. And now you can see the success true and data only for that user. This time, no password. But as I said, we need to be able to protect our routes. For example, this user details page should be private. And to do that, we can also use middleware. This time, we can think of it as authentication middleware. So right within middlewares, create a new file called auth.middleware.js and create a new function, const authorize, which will be equal to an asynchronous function that accepts the request, the response, and the next. and opens up a try and catch block. In the catch, we can run res.status of 401, which means unauthorized, and return a JSON output with a message of unauthorized, as well as pass some additional error information in form of the error message. But in the try, we can try to get access to the user's token by saying let token, and then having an if statement where we check for rec.headers.authorization, and if rec.headers.authorization starts with bearer. Typically, when you pass a token through the rec headers, it starts with the word bearer. It's just a protocol. So if that is the case, then we know that the token will be there, and we can say token is equal to rec.headers.authorization.split, and we'll split the word bearer and return just the second part of that string, which will be the actual token. We can go outside of that if and check if there is no token. In that case, we can return a res.status of 401 and a message of unauthorized. Else, if we do get the token, we have to verify it by saying const decoded is equal to jwt.verify, and you have to pass the token and our JWT secret coming from our env config. So make sure to import it from here, and also make sure to import the JWT from JSON Web Token. Once we decode it, we can check if the user still exists by fetching it from the database. Const user is equal to await user.findById, and we'll use the decoded user.user ID. If it doesn't exist, we'll simply return once again a 401 of unauthorized. And if it does exist, we'll attach the user to the request that is being made and then forward it over to the second part of the request. So basically what this middleware is doing is it's trying to find the user based off of the token of the user that is trying to make the request. It looks if it's there, it decodes it, verifies that that is the user that is currently logged in, and then it attaches it to the request. So later on, when we're doing something, we can know who exactly is making that request because now we have this additional information. So in simple words, let's say that somebody is trying to make a request. Making a request to example get user details. Then we call this authorize middleware. We verify who is trying to do it. And if they have permissions or if valid, then we go over to the next step and give access to the user details. So how can we actually put this authorized middleware to use? Well, let's head over into our user.route.js. And remember what I told you, we'll authorize the user details page. So only the user that is currently logged in can see its own details, no one else. And the only thing you have to do to make it work is import that authorize from /middlewares/auth.middleware.js. Oh, and I think I forgot to export it. So this was supposed to be const authorize, and we can run export default authorize. And the only thing you have to do is add it right here after the path, but before the next function. This is why it's called middleware, because it is in the middle from when you start making a request to when you end it. And in case you want to add a second middleware, maybe like error handling middleware, you can add it right here as well. And you can keep chaining as many middlewares as you want, as long as they all end in the next, because they'll forward it over to the next function. But now this get user will actually have access to the user object because we authorized it beforehand. So let's put it to the test. If I retry the same request that we made not that long ago, where we got successful user details, now you'll see 401 unauthorized. Okay, this is good. We don't have a token and it's not working. Exactly what we wanted. But now to pass this authorization, we'll have to sign in to get a token. To get it, you can just go to API v1 auth and then /sign in and enter your email and password that you use at the start. If you forgot it, you can just create a new account by going to sign up and passing over your email, name, and password. So now I'll click sign in. And of course, this is not a GET request. It's going to be a POST request. So if I click it, There we go, user signed in successfully, and we got our token. Before copying the token, first copy the user ID and add it right here to the request, where we're gonna go for API v1 users and then user ID, and also copy the bearer token and make a GET request to this URL. But now within auth, you can select a bearer token and paste that token right here. This should allow you to fetch the details of this user. So click send, and we got unauthorized, but I think I know why that is. It's because we haven't defined our user. So if you head over to user middleware, I think we forgot to import this user right here. It's supposed to be coming from /models user.model.js. So now that we fixed that issue, thankfully we have proper error handling here, let's try to remake that request. This time with a token. And there we go, we get back the information. But if we remove this token from there, you can see that we don't have the permission to access it. So hopefully that makes sense. That is how we authorize or protect certain routes by allowing only specific users to see them. You can always extend this to add stricter rules. For example, for only admins to be able to make requests to get all users. The only thing you have to do is add a check if that user is an admin or a regular user. You can do that using the same authorized middleware, or you can create another piece of middleware only for that. And talking about making stricter rules for your apps, typically, there's always one or two nasty users that'll try to spam your APIs or websites by making too many requests, one after another. That's not good because it's slowing down your server and increasing the costs. And right now, they can totally do that. I mean, check me out. I'm just making tons of requests right now. And imagine if they coded a bot to just spam thousands of them. So in the next lesson, I'll teach you how we can restrict the number of requests a user can make in a certain period of time. Almost every production app does this, so let me teach you how to do it. Just for a second, imagine you run a small coffee shop. And then at one moment, hundreds of customers come in and order 500 cups of coffee each. That would significantly slow down the service, right? Well, that's exactly what happens to websites and APIs and apps without rate limiting or bot protection. Just see how congested it can be. Transaction in progress, and all the users will be stuck, waiting for their data for days. Rate limiting is like a rule that says, hey, you can make a certain number of requests in a given time, and it prevents people, or most commonly bots, from overwhelming your servers with too many requests at once, keeping your app fast and available for everyone. And of course, even more important to say is that not all website visitors are human. There are many bots trying to scrape data, guess passwords, or just spam your service. Bot protection helps you detect and block this kind of bad traffic so your platform stays secure and functional. And that's exactly what we'll do with our API to make it safe and secure. If you haven't already done that, click the ArcJet link down in the description to be able to follow along and see exactly what I'm seeing, and then sign up for free. Once you do that, enter your API name. I'll say subscription tracker and create. And you'll be able to choose between many options of the services you can integrate it with. From Bun to Bun and Hono, Deno, Nest, Next.js, Node.js. In this case, Node.js and Express is the perfect fit for us. So let's just copy this ArcJet key and click Continue with Node and Express. Before we follow the docs, let's just head into our app, into .env.development.local, and let's add ArcJet environment variables. That'll be ArcJet_key is equal to this key that you just copied, as well as ArcJet_env, which is set to development, so we know we're currently in the development environment. We'll also head over to our env config and add the ArcJet env right here, as well as ArcJet key, so we're properly exporting them. Perfect, and it seems like WebStorm doesn't know about the word ArcJet, so I'll simply add it to my dictionary because I'll be using it much more frequently from now on. With that in mind, let's follow the steps outlined right here. We have already installed Express. Now we have to install ArcJet. So let's just copy this command. And in our second terminal, we can just run npm i arcjet/node. While that is installing, let's set up our key. Perfect, this is exactly what we have done. And now we are ready to add some rules. What you could do is add those rules directly within the app.js file, which is totally okay, But in this case, we'll actually do it in a separate file to keep our code base tidy. So back in the code, create a new middleware file, which I'll call arcjet.middleware.js. And before we set up the arcjet middleware, we first have to configure an active instance of arcjet, which I'll do in the config file. So let's go ahead and create a new file called arcjet.js within the config. And we can get started by copying this const aj from arcjet and then pasting it right here. This will give us a head start on the configuration. We'll have to import a couple of things, such as import arcjet, as well as, in curly braces, shield, detect bot, as well as token bucket. All of this is coming from arcjet. So first things first, we have to get our site key from arcjet and set it as an environment variable coming from process.env.arcjet, or in this case, we can just say arcjet key coming from env.js like this. We can leave the characteristics as they are, track requests by IP address. Then we have a couple of rules. The first rule is the shield, which protects our app against common attacks, like SQL injections. This is super convenient because it allows you to focus on implementing your API's business logic while arcjet handles the protection side. And we also have a bot protection, where you can also specify different rules of how you want to protect them. In this case, we're setting the mode to live, and under allow, we have category search engine, which allows search engines to access our site. If you want to turn it on for monitoring or preview, you can do that as well. I'll keep it as it is. And right below, we have something known as a token bucket. And this is used for rate limiting. If you head over to the docs for the rate limit configuration, you can see that each arcjet rate limit rule has its own configuration depending on the algorithm used. They start from the type and then the algorithm. There are different options that we can pass into it and characteristics. But if we scroll a bit down, you'll be able to see a detailed explanation for each one of the parameters that we pass into the function. So if I put this to the side, you can see that an interval can be a number or an integer. It is supported for these types of algorithms. In this case, we're using a token bucket algorithm. And for the token bucket, if you set the interval to 60 and the refill rate to 10, the bucket will refill 10 tokens every 60 seconds. Here you can learn more about the refill rate and the capacity. Arcjet is using actual rate limiting algorithms, not just a set number of calls that each IP address can make. The default option right here is that it refills 5 tokens per interval, refills every 10 seconds, and the bucket capacity is 10 tokens. We'll soon see if we can break that by trying to make too many requests. Great. This is all it takes to configure arcjet. So let's head over into our middleware to use it. We can import aj coming from .config/arcjet.js, and we can create a new function called arcjet middleware. It has the request, the response, and the next. We can open up a try block as well as a catch block. And if there's an error, we'll simply console log that error, but I will prepend arcjet middleware error, and then we can display the error message right after it, just so we know where the error is coming from. And then we will call the next and pass over that error. Finally, in the try, we can start with this. Const decision is equal to await aj dot protect. And the only thing we'll pass in is the request. So we're saying protect this request and tell me your decision. Should it be denied or should we let it through? If decision dot is denied, which is a function, so make sure to call it right here, we'll open up a new block and then we'll figure out what is the reason for the denial. If decision dot reason dot is rate limit, if that is the case, we'll return a status of 429 with a JSON message of error, rate limit exceeded, or too many requests. We can actually put this in one line right here. We can have another if statement right within it, and we'll say if decision dot reason dot is bot. Okay, so we're implementing bot protection here. In that case, we'll return a redstat status of 403 and say bot detected. If it's neither one of these, but if it's just denied, we'll return a 403 and say access denied. Now, outside of the if, that means that we're not denying the request to pass through. We'll just simply say next. Go to the next step, whether that's to create a subscription, create a user, or whatever you wanted to do with that request. Maybe order a coffee. So with this, we're implementing that additional layer of protection. Now let's export default that ArcJet middleware, and let's put it to use right within our app.js. Here we have all sorts of different middlewares, and we can also add the app.use ArcJet middleware, and make sure to import it from middlewares ArcJet middleware.js. So what do you say that we put it to the test? Let's just go back to ArcJet middleware one more time and make sure that we have properly implemented it. Oh, it looks like we're using a wait here, so I need to add async right at the top. And let's check out our ArcJet file and make sure to export default the AJ configuration instance, so we can use it right here to protect us. And if you head over to the ArcJet config, just to make sure we're doing good, this is supposed to be coming from @arcjet/node. If we fix that, you'll see that our subscription tracker is now running on localhost 5500. Now, just before we test it, I want to explain how this token bucket algorithm works in a bit more detail. See, this algorithm is based on a bucket filled with a specific number of tokens. Each request withdraws a token from the bucket, and the bucket is refilled at a fixed rate. Once the bucket is empty, the client is blocked until the bucket refills. This is useful when you want to allow clients to make a burst of requests and then still be able to make requests at a slower rate. For this to work, alongside providing the refill rate, the interval, and capacity, you also have to choose how many tokens will you deduct once you determine each request. And this is happening when we call the AJ protect. So if you head over into ArcJet middleware, you'll have to provide a second parameter to AJ.protect of requested set to 1, which means that you'll take away 1 token from the bucket. And to test it out, we can now go back to our HTTP client and try to spam a lot of requests. So I'll just keep pressing send. There we go, transaction is in progress. And at one point, we reached 429 too many requests. Rate limit exceeded, which is exactly what we wanted. Now, if you try making another, you'll be able to do it because of the token bucket algorithm, which is slowly filling it up. But if you once again start spamming, you will once again automatically be blocked. And check this out. Within ArcJet dashboard, you can see all of the requests that are being made. You can explore more details about the ones that pass through, see the complete headers, the path, the home, as well as the IP address that try to make them, as well as whether it was allowed or blocked. In this one, it says it's okay. But if you head over into one that was rate limited, you can see that it was denied for the reason because of rate limit, and it will be reset very quickly. Perfect. ArcJet also allows you to further configure it, so you have even more options of protecting yourself. And if you head over into analytics, you'll be able to see exactly what is happening on your website. Are people spamming it, or are they using it politely? So with that in mind, now you know how to secure your APIs, but keep in mind that ArcJet also works with web applications, so you can very easily protect your web applications too. Great. Now that we know that we're protected, let's focus on our application's main functionality, and that is creating and tracking the subscriptions. Let's start with the most important part of our API, creating subscriptions and tracking them and canceling them. We'll do that by creating a new file in the controllers folder, which I'll call subscription.controller.js. Within here, we can create a new function, export const create subscription, which will get access to a request, a response, and next, and we'll open up a try and catch block. In the catch, we'll get the error, and we will simply pass it over to the next middleware. And in the try block, we can create a new subscription by making it equal to await subscription with a capital S, because this is referring to a subscription model, .create. And then we can pass in an object of the subscription details we want to create, where we will spread the entire request.body, meaning everything that the user passes into this call, as well as user is set to rec.user._id. because we have to know which user is trying to create this subscription. And this rec user is not a part of the rec body because it's coming from the auth middleware that we put before creating any subscription. To do that, we have to go over to subscription routes, and where we have create subscription, we have to call the authorize function right here one step before it. This will populate the request.user with the user information that's currently logged in. And if they're not logged in, they won't be able to create a subscription. This is a very simple thing to do, but not everybody does it. You should always validate your request with necessary authorization procedure before creating any kind of document in your application. And I've explained all of that in detail in my Ultimate Next.js course, where we write type-safe and secure API endpoints. You can see just how many validations we have, and each lesson has its own GitHub commit so you can track the code. So after watching this course, if you want to go from being a backend developer into being full stack, Next.js is your best bet. With that in mind, once we create the subscription, if the user is authorized, let's just return a res.status of 201, which means created. And we can also pass in an object where success property will be set to true, as well as data will be set to be the subscription that was just created. Now we can get back to the subscription routes, and instead of simply saying title create subscription, after calling authorize, here we can call create subscription, coming from controllers subscription.controller.js. So let's test it out. I'll go to my HTTP client and I'll head over to API v1, not users, but subscriptions. Once again, make sure that your authorization header is right here, but it is possible that it will be expired if some time has passed. So if that is the case, you'll have to log in once again and then add it here, just to simulate the fact that you're logged in. After that, we can change this to a post request, and we have to fill in the post body. You have to fill it in with all the necessary information, such as the name of the subscription, like Netflix Premium, the price, $15.99 with a currency of USD, frequency of monthly, category of entertainment, I believe we used lowercase characters, and for the start date, you can put any date in the past. Feel free to copy what I have right here, 2024-02-01, and I'm not sure if you need these additional characters as well. Below this lesson, or maybe in a GitHub README, I might include this entire post body just to make sure that you don't have any issues with the validation while trying to create it. It looks like we got connection refused, which typically means our server is down, and it is because our subscription create has to be awaited, and I forgot to provide async right here at the top. So if we fix it, we're back on track. Our subscription tracker is running on localhost 5000, and our database is connected as well. So let's retry that request. Transaction in progress. And there we go. 201 created, success true, and we got the data for this newly created subscription. Beautiful. And as before, this route is completely authorized. So if you copy this auth token for a second and remove it and try to create a subscription without the auth token, you'll get 401 unauthorized. So let's make sure that we have it here. Now let's create another controller that'll give us all subscriptions created by a user, just so we can be sure that we have indeed created a subscription. We can do that by saying export const get user subscriptions, which will be equal to an asynchronous function where we get the request, the response, and the next. In the try block, we can do something, but in the catch block, we get the error, and we can simply forward it over to our error handling middleware. And in the try, we can check if rec.user.id is not equal to the rec.params.id. What does this mean? Well, this means check if the user is the same as the one in the token. So if the currently logged in user is trying to get its own subscriptions, if we're trying to get it for somebody else, it should not work. So we can create a new error by saying new error, you are not the owner of this account. We can also set the status code of 401 unauthorized and throw the error. But if we are the rightful owner, then we can get all the subscriptions by saying const subscriptions is equal to await subscription.find, where the user is equal to rec.params.id. And finally, we can return them by saying res.status of 200. That JSON success is true and data is equal to the fetch subscriptions. So if we head back over to routes, where we are trying to get the user subscriptions, which is this one right here, we can now also run authorize right here and then call the get user subscriptions. Make sure to import it at the top as well. So the only thing we have to do to test it out is get our currently logged in user ID. We can get it if we go to API v1 users, and this will give us our ID. So copy it and then modify the URL to API v1 subscriptions /user / and then pass that ID. Now make a GET request and you'll be able to see success true and data, which is consisted of an array of all of the currently active subscriptions. There is only one, so we can see it. And the pretty cool part is that we had the start date, but as you can see, the renewal date has been automatically calculated for us based on that math function that we added that was executed once this document was created. Now you could totally go ahead and continue implementing the rest of these controllers. You already know the drill. You have to create a controller and hook it up to the route. You can do it on your own for the get all subscriptions as well as get subscription details. Try doing your best of implementing it. But later on, we might implement some of these together. But for now, let's move to the most interesting part of this project. And that is triggering email reminders to let us know that the subscription renewal date is coming, so we can turn off our subscription on time. Let's do that next. In this lesson, let's implement workflows. A workflow is basically like a message queuing or task scheduling system, where the client or an API request triggers a specific workflow to happen. In our case, we want to schedule a lot of email reminders before our users hit their subscription deadlines, giving them more time to think about whether they want to cancel their subscription or keep it going. And for that, we'll use Upstash. Before we start implementing it, I wanted to quickly go over our workflow algorithm, or in other words, how will our workflows be triggered and how will they behave? Step one is, of course, to trigger the workflow. The workflow begins whenever a user creates or submits a new subscription. We're going to pass the created subscription ID to our workflow. After that, we want to retrieve the subscription details. Specifically, we want to extract the subscription ID and then search for the corresponding subscription in the database. Finally, we'll run some checks to see if a subscription doesn't exist. Then we have an error and we kill the process. But if a subscription does exist, we'll check its status. If it's inactive, then we're going to kill the process. But if it's active, then we want to check out the renewal date. If the renewal date has passed, then we're going to log this information and exit. But if the renewal date is in the future, the reminder loop begins. And then we can schedule predefined reminders. For example, 3, 7, or 14 days before subscription deadline, and send those emails. And this process will repeat for all the reminders in the list, and after it's done, the workflow has done its job. Let me show you just how simple it is to implement it. We'll use Upstash. So if you haven't already created an account, you'll have to create one now. Click the link in the description to be able to follow along and see exactly what I'm seeing. Head over to Login or Create a New Account and choose one of the options. Head over to Workflow and copy those environment variables. I'll copy the QStash URL and head to my .env.development.local, where I'll say Upstash, and I will render an upstash_URL and make it equal to the string that I just copied. We also want to get the QStash token. Ooh, that's my bad. This was supposed to say QStash, not Upstash. This will be QStash token. And finally, we have the signing keys. So let's copy both of these. I'll copy first the name, paste it here, and I'll copy the second name. And now we can add those two keys. There we go. It should look something like this. And now that we have our ENVs, we can install Upstash client. I'm going to do it by following the quick start for Express. And the first step is to install Upstash workflow. So I'll copy this command without the bash at the start. Just npm install @upstash/workflow. We have to set up our ENVs, which we have already done. And we won't necessarily follow this entire tutorial. I mean, that will kind of defeat the purpose of you watching this video. So let me teach you exactly what we have to do next. We'll keep our code super clean by creating an additional configuration file. You can see how much sense it makes to separate all the configs into their own files. I'll call it upstash.js. Here, I will import client as workflow client coming from @/upstash/workflow. And I'll also import our envs. Oh, I think I forgot to add them in our .env config. So right here, I'll get the qstash_token as well as the qstash_URL. We'll only need those two for now. So here we can import them by importing qstash_token as well as qstash_URL from ./env.js. And finally, let's simply export const workflow client is equal to new workflow client. And to it, we have to pass an object within which we can specify a base URL of qstash URL as well as the token equal to qstash token. That's it. That's the config. And now we can create a new file for running all kinds of different workflows. Let's do it under routes and create a new route called workflow.routes.js. Within here, we can import router coming from Express. We can initialize a new workflow router equal to router, which we call like this. And we can define a route, for example, a basic get route for now. And finally, don't forget to run export default workflow router. That way, we can use it within our app. Of course, we have to replace this with real workflow logic. So let's head over into the app.js, and right below the subscriptions, let's duplicate it and call it workflows. And just call the workflow router and make sure that it's coming from workflow routes.js. Now, as you know, every routes file has to have its own controllers file. So create a new file called workflow.controller.js. Within here, we can create a function which will be responsible for sending reminders by saying export const send reminders. And this one will be different from a typical rec and res route. This one will be wrapped within serve. This serve is coming from Upstash Workflow Express. So we can say const destructure the serve and say require @upstash/workflow/express. And when packages are written as ESM modules, you could automatically use import to import them. But because Upstash Workflow was likely written using CommonJS, import won't work directly, so we need to use require to import it. But in our package.json, we have switched type to module, which means that we only can have imports. So one way to go over that and still allow this single require statement is to say import destructure create require, and that's coming from module. And then we can say const require is equal to create require and import that meta.url. And this will allow us to nicely import this Upstash workflow. Now we are wrapping this function with a serve, and the only thing it'll have is an async function that'll give us access to the context of that workflow. And we can then open up a new function block. That'll look something like this. Within here, we first want to extract the subscription ID from a specific workflow. So let's say subscription ID is equal to context.requestPayload. So when we trigger a specific workflow, we will pass the ID of the subscription that workflow is for. Then let's fetch the details about the subscription by saying const subscription is equal to await fetch subscription. And to it, we can pass the context as well as the subscription ID. And this fetch subscription function is a new function we can create below by saying const fetch subscription is equal to async will accept the context and the subscription ID, and will return await context.run. So here we're starting the context for get subscription. And when it happens, we'll open up a new function block where we'll simply return subscription.findById, and we'll pass over a subscription ID, and we will populate it with user information, specifically name and email belonging to that user. It looks something like this. make sure to have these two return keywords at the start of this code block and at the start of this one, because otherwise functions return undefined if you don't explicitly return something. Great. So now we're starting the context of getting the subscription and we're returning it right here. Next, we'll check if there is no subscription or if the subscription.status is not equal to active, then our job is done here. We can kill the workflow. So let's simply say return, meaning exit out of this function. Don't send a reminder. Else, we have to figure out when is the renewal date. So let's say const renewal date is equal to, and now we could use the regular JavaScript date object and then wrap our renewal date with it, but we'll have to do a bit more date and time calculations here. And for that, I prefer to use a very lightweight package called day.js. So in my terminal, I'll say npm install day.js, and let's import it at the top. I'll do it right here by saying import day.js from day.js. Oh, and don't forget to import the subscription because we're using it right here. So that's going to be import subscription coming from models subscription model.js. And we can have it below because it is a local import. Great. So now we can wrap our renewal date with day.js object, subscription.renewal date. And then we can have another check and see if renewal date is before, and then we can just pass day.js and call it. If you call it like that, it basically returns the current date and time. So we're checking if renewal date is before the current date and time. If it is, well, then we're going to simply return a console log saying something like renewal date has passed for subscription with this ID. And we can also add stopping workflow at the end. Nothing to do there. And we can just return, meaning exit out of this workflow. Finally, now that we have figured a criteria for when we want to exit out of the workflow, let's actually figure out what the workflow will do once we're in it. We can do that by creating a list of different reminders for days when we want to send them. So I'll say const reminders is equal to an array, and we can do something like 7 days ahead, 5 days, 2 days, and maybe 1 day. So we have different reminders. After that, we can open up a new for loop and say for const days before of reminders. So from each reminder, we'll get the number of days before when we want to send that reminder. And then we'll say const reminder date is equal to renewal date dot subtract. And we're going to subtract the number of days before just like this by saying reminder date is renewal date and then subtract days before. So let me give you an example of that. Let's say that the renewal date is maybe 22nd of February. In that case, the reminder date is 15th of Feb, which is 7 days before. But then we also have a second reminder, which is 5 days before. So that's going to be the 17th. Then we're going to have a 20th and finally 1 day before on the 21st. So we're going to be in a loop each time for each one of these reminders. Then we want to figure out if reminder date that is after the current date and time, so day.js, that means that we want to put it to sleep until it's ready to be fired. We can do it by creating a new sleep function. I'll create it right below and I'll call it const sleep until reminder. And it'll be equal to an asynchronous function that accepts the context, the label it wants to fire, as well as the date. And here we can simply console.log and say something like sleeping until label reminder at specific date. And more importantly, we can await context.sleep until this specific label and this specific date. So date.toDate. Hopefully that makes sense. We're putting that reminder to sleep until it's time to trigger it, for which we can have another function, const trigger reminder. We'll make it equal to a function that accepts the context as well as the label. And then we're going to return await context.run for this specific label, and it'll run the following code. For now, it'll simply say console.log triggering label reminder. And then later on, we can send an email here. Or it doesn't even have to be an email. It can be an SMS. It can be a push notification. It can really be anything you want to do. You can run any kind of custom logic whenever this reminder is triggered. But keep in mind, this don't have to be just reminders. This could be anything you want to run periodically, or you want to run based on some kind of algorithm or logic. You are in control. We'll figure out how to send this email very soon, but for now, let's put this reminder to sleep when it needs to sleep, and let's trigger it when it needs to be triggered. In this if statement, I'll say await, sleep until reminder, and I'll pass a context to it, and I'll pass the label. The label will look something like this. Reminder, days before, this is going to be the actual number, like 5 days before, and then finally, I'll pass the reminder date. Outside of this if statement, we're actually ready to trigger the reminder, so I'll say await, trigger reminder, we're going to pass in the context, and we'll say reminder for 5 days before, for example. So let's figure out these functions. First, we're fetching the subscriptions. We're checking if that renewal date is maybe in the past, or if the subscription doesn't exist, or if the status is not active. In all of these cases, we just stop the reminders from going. But once we figure out that it is an active subscription and it has a renewal date that is in the future, we map over all of the reminders that we specified, like 5 days before, 7 days, 2 days, 1 day, and then we figure out when to put it to sleep and when to actually trigger it. And we use these helper functions, such as sleep until or trigger, to make it do its job. And let's trigger the workflow. We'll do it right after the subscription gets created. The only thing we have to do is say await, workflow, client, this is coming from Upstash, so imported at the top, dot trigger, and we're going to pass in an object of additional info for this workflow we want to trigger. First, it needs a URL. So which API endpoint do we have to call to be able to run this workflow? It'll be starting with server _URL, and you'll have to add it over in your env.development.local. So scroll to the top, and if you haven't already, and I don't believe you have, you can add this server _URL is equal to, and put your current localhost address, http:// localhost 5500. Usually, you would have to deploy the entire app and use a production URL to test any kind of scheduling type of workflow, or use something called ngrok to do it. It has a super complex setup. But luckily for us, Upstash provides an easy local development server that won't just save you time and a lot of headache from going through complex setups, but also save you money from running all of those test workflows. You have unlimited tests here. So let me show you how to do it. I'll open up a third terminal, which will run our local development server. And for now, I'll run npx @upstash/qstash-cli dev. It'll ask us whether we want to install that package. I'll say, why? Go ahead. As soon as you do that, in the terminal, you'll get a URL and a dummy token. Copy those and add them over to .env.development.local. Let's add them below current Upstash envs, and then move the original ones over to our second .env file, .env.production.local. So this is going to be Upstash, and I'll paste them right here. Oh, and this is important. Check out this sample curl request that Upstash has given us to test this out. Hidden within it, there's a qstash URL. So copy the starting part of this up to the 8080 part, and then head back to the development part and say qstash_URL and make it equal to this http://127.0.0.1.80.80. So now we have two different instances of Upstash, one for testing in development and one for production. Also, in production, we need these qstash current and next signing keys, but in development, we don't actually need them. So I will completely remove them from development. You need to remove them in order for everything to work. Let's actually copy this entire curl request, and let's leave this third terminal to be running. I'll rename it as Upstash. The first one will be our own server, so I will rename it to server. And within this terminal, which I'll simply call terminal, we can run some additional commands. such as running this curl command that was given to us by Upstash. I'll press enter, and you can see that we get back a message ID of message 2kxd. This is a random workflow ID generated for us in the terminal, which means that our workflows are indeed generating locally. But let's not forget the workflow routes. If you think about it, we never actually got the opportunity to use the send reminders workflow that we created not that long ago. Of course, this one right here is the one I'm referring to, send reminders. So we'll call it once we hit this endpoint, which is supposed to trigger the workflow. I simply have to say send reminders and import it from controller's workflow controller.js. But then when are we actually going to fire it? Well, the answer lies in the subscription controller, because here we have defined the URL. So it's going to be API v1 workflows and then /subscription/reminder. And it is a post request. So let's say workflow router.post /subscription/reminder. And then we call this send reminders function. Now we are ready to test it out. Back in our HTTP client, I prepared my route of localhost 5500 API v1 subscriptions. I have my bearer token right here, as well as the body of the new subscription I'm trying to make. This is a subscription for JS Mastery Pro Elite membership. We have the price, the currency, and the category, as well as the start date. So what do you say that we give it a shot? I'll click send, and we get a 201 created. That's amazing. But hey, this worked before. This is nothing new. So what matters more here is that now, alongside the newly created subscription, we also get a workflow run ID. It ends with ONG. Okay, so let's see if we get anything in the terminal. Back into the code, if you go to the Upstash terminal, you'll see that we have some kind of a message ID with a workflow run ONG. But now if you head into your server terminal, it looks like we got a small type error. This converting circular structure to JSON, especially when mentioning a Mongo client object, typically refers to forgetting to pass an async or an await before some kind of a mongoose action. So if we head over into workflow controller and pay attention to the only mongoose call we're making here, subscription.findById, we actually have to turn this function into an asynchronous function. That'll resolve the error. Also, if I scroll a bit above, you'll notice that here I said subscription status is not active, but this active is actually an undefined variable. What I meant to do was say active within string signs, because the status is literally a string of active. So now that I fixed those, let's just render another subscription. We get true, this time ending with 6KB. And if I get back, you can see sleeping until, reminder 5 days before, and reminder will happen at, and of course, this date and time will be different for you. So this is great. It means our workflows are working. But just seeing these workflow IDs and console logs within terminal is not that fun. So let's head into the workflow controller and scroll down to the part where we left a comment. When we trigger a reminder, we want to do something. We want to send an email or an SMS or a push notification. And that's exactly what we'll do in the next lesson. Then we'll be able to utilize the full power of the flexibility of these workflows to trigger custom email reminders. So let's do that next. In this lesson, I'll teach you how to use NodeMailer, a free module for Node.js applications that allows for easy email sending. And of course, we'll integrate it with our workflows. So let's run npm install NodeMailer. I'll put that straight within our terminal. And to make NodeMailer work, we'll use our Gmail account as our email transporter. So head over to your Gmail account, go to settings in your profile, and for this to work, if you haven't already, you'll have to turn on the two-step verification for your email. It's like an extra layer of security. It's good to have it anyway, but in this case, you'll have to have it for NodeMailer to work. So just follow the steps to turn it on. But if you're a good developer that cares about security, I believe it's already on for you. Then once you enable it, you select your account and click Manage Your Account. Right here on the homepage, search for App Passwords and click the first link under Security. Then enter the app name. In this case, I'll choose Subscription Tracker and click Create, and then just copy the password you were given. Back within your editor, head over to .env.development.local, and at the bottom, add a new node mailer comment. And here we can say email password is equal to, and then you can paste the password that you just got. And here you can also export the email password. Then let's create a new configuration file. I think you can see how useful having this structure is. And I'll call it nodemailer.js. Here we can configure a transporter using Gmail as a service by saying const transporter is equal to nodemailer.createTransport. And make sure to import nodemailer right at the top from nodemailer, like this. Next, we can define service as Gmail, and then auth equal to user will be equal to your account email. In my case, it'll be JavaScript Mastery 00@gmail.com. Choose the Gmail account that you enabled your two-step verification on and through which you created your app password. It has to be the same one. And then right here, we can put the pass, which will be equal to email_password coming from /env.js. Now we can create a common reusable HTML templates for all different kinds of reminders. To create it, create a new folder called utils, like utility functions. And within utils, create a new file called email-template.js. I've just used v0 to quickly generate a template. It's basic HTML and CSS, and I told it to include all the important things, such as username, email, subscription date, and all that good stuff. So I'll leave it either below this lesson or within the assets part of the GitHub README of this project. So just copy from there and then paste it here. You'll notice that it is a single function called generate email template, which is basically just a div with a lot of CSS styles, but then it mentions the subscription name, the plan name, the username, and all the important stuff that we pass through it. We also have different templates like 7 days before, 5 days before, 2 days before, and then we call the actual function and generate the subject and the body of that specific email. Once again, nothing special is happening here. We're just returning HTML. Now let's put it to use. Let's write the actual logic that'll send the reminder email. We can do it within a new file within the utils folder, and let's call it send-email.js. Within here, we can export const send reminder email, which will be equal to an async function. It'll look something like this. And as the first and only parameter, it'll accept an object, so we can destructure it. And it'll have the to property, who we're sending the email to, the type property, and the subscription. So now that we have destructured those, we can say if there is no to, or if there is no type, we can simply throw a new error and say something like missing required parameters. If it exists, we can create a new template by calling the email templates and calling the find method on it, where we're going to look into the type that we have, and then based on the t.label, we'll compare it with the type that we have, and that'll be the template we'll use for this specific reminder. If it's 5 days until, we'll find that in the email templates, and we'll say 5 days reminder. If it's 7 days, it'll be 7. If it's 1, it'll be 1. Once we have the template, we can check if we have it. If we don't, we can say invalid email type. And finally, we can form an object containing the full user info. I'll call it mail info. Username is subscription.user.name. Next, we're going to have a subscription name, which will be equal to subscription.name. Let's spell it properly. After that, we're going to have the renewal date, which will be equal to day.js subscription.renewal date. And I'm going to even format it to MMMDYYYY. This is just a format where it'll say something like January 1st, 2030. or something like that. We're going to also have a plan name, so that'll be the subscription dot name. We also have the price, and it'll be equal to, let's format it, subscription dot currency. After that, subscription dot price, and then finally, in parentheses, we can render the subscription dot frequency. So it's going to say something like USD 10 monthly. And we can also render a payment method, which will be equal to subscription dot payment method. Perfect. Finally, let's form the actual message by saying const message is equal to template dot generate body, and we'll generate the mail info. And finally, there is the subject of that email, which will be equal to template dot generate subject. We'll pass the mail info. And finally, we can form the final mail options by saying const mail options is equal to from will be equal to the account email, to will be equal to subject will be equal to subject, and finally HTML will be equal to the message that is coming from the template. Oh, and let's make sure that we know where this account email is coming from. It has to be the same as the one that we have chosen right here in node mailer config. So we could actually separate it from here and export it by saying export const account email is equal to, and now I can copy this string, put it here, so I can refer to the account email, and then we're exporting it, and back in the send email, we can import this account email coming from config nodemailer.js. Finally, from the node mailer, we'll also import our instance of the transporter with our configuration. And now that we have all the information, we can say transporter dot send mail with all the mail options. And as the second parameter, we're going to get access to the error or the information for that email. And if there is an error, we will simply return a console log and say error, as well as error sending email. Else, we will simply console log email sent, and I'll also add the info response of that email. Now, where are we going to call this send reminder email function from? Well, we're going to call it from the workflow controller. So head over into the workflow controller and remember this comment. We're finally back right here. I'll simply say await send reminder email. Make sure to import it from utils sendemail.js. And to it, we have to pass a couple of things. It'll be an object of the to property, and we want to send it to subscription.user.email, so whoever created that subscription. And we have to pass the type of the subscription, which will be equal to reminder.label.subscription. So either 5 days until, 7 days until, 3 days until, and so on. Let's open up our terminal to see if we have any errors, because we have modified a lot of code. Looks like we have one error in workflow controller line 49. And that is right here where I added await. To be able to add await right here, I have to make the function I'm calling the await within async. So let me add it there. And that fixed the error. Now we have another error in sendemail.js. So if I head over here, we're importing the transporter, but are we actually exporting it? Oh, looks like we're not. So let's run export default transporter. And with that, that second error is now gone. Subscription Tracker API is running and we're connected to the database. So back in our HTTP client, let's try to create a new subscription. This time I'll do it for Amazon Prime in a currency of USD, category entertainment, and feel free to test it with different days right here. I'll choose a date that is 7 days from my current date. You can of course choose a date that is 7 days from your date. And if I now click send, of course we get a 201. We've gotten good at getting those and not errors. We get back the subscription that we created with automatically calculated renewal date, and we got a new workflow that we ran. Oh, it looks like I have another reference error. It is happening within the workflow controller. I haven't defined a subscription. So let me quickly head over into the workflow controller. And here, it looks like I'm referring to a subscription, but I don't really have access to it within this trigger reminder function. So when we're calling this trigger reminder, and we're calling it right here, maybe as the third parameter, I need to pass the actual subscription. Here, we do have it, as you can see. Then I can accept it as the third parameter, subscription, and now we should have access to it. What about the reminder? I don't think we have that either, and it's not like we can very easily pass it. But this reminder label is basically just this label, which we're already passing through. And this label has to exactly match the one within email templates, where it says 7 days before reminder, 5 days before reminder, 2 days before reminder, and 1 day before reminder. So that's 7521, and then we have the final. I think I can even get rid of this final. We can just keep it 7521, and it has to match exactly. So let's copy it, and let's compare it. Here I have reminder days before, but actually we have to start with the number, then days before, and then finally reminder like this. So that's gonna then look something like this, 2 days before reminder. Perfect. So now we're passing that as a label. So the type can be just label, and then we can pass the entire subscription equal to subscription. We need it to send that email reminder. So let's test it once again by creating another subscription. And take a look at this. Sleeping until reminder 5 days before. Email sent. Okay. And we get the ID of the email. Beautiful. Now, of course, this email will get to the email of the user that created the subscription. So if you want to know which one is that, you can copy the ID of the user that created the subscription and then go to get localhost API v1 users and then paste over that user ID, and you'll get your email right here. And check this out. What a nice caption right here. Reminder, your Amazon Prime subscription renews in 7 days. Hello, Adrian, your Amazon Prime subscription is set to renew. Plan, price, payment method. If you'd like to make changes or cancel the subscription, visit your account settings before the renewal date or contact our team. Of course, none of these links are real, but you get the idea of what is possible by creating your own API, now with workflows allowing you to trigger and send emails to people that want to get reminded. Now, let's try to make another subscription, but this one will have a closer renewal date. So we're not looking to trigger the 7-day reminder, but maybe the 2-day or 1-day reminder. Right now, it's February 7th for me, so I'm gonna make it seem like I subscribed on the 9th of January, which means that there should only be 2 days left until the renewal on February 9th. You can change it depending on your current date and time. But before we trigger it, there's just one fix that we have to add in our workflow controller, and that is right here where we're triggering the reminder. Currently, if we're only 2 days away, what would happen is we're gonna go into this for loop and we're gonna trigger all of the reminders in the row, 7, 5, 3, 2, 1. But instead, if we're already so close to the renewal date, we have to have an if statement right here and check. If now is same reminder date, day. Only if that is the case, then trigger this reminder. Oh, and if I'm not mistaken, instead of using the word now, we can just call the day.js as a function, because that will render the current date and time. And then we're checking whether currently is the same as the reminder date. Only then send it. Now let's trigger that new subscription that has a renewal date that is only 2 days away. There we go. We get a 201 created with new subscription data and a new workflow run ID. Back in the terminal, we now only see one email sent instead of like 7. And most importantly, take a look at this. Email caption changed to a bold saying, "Final reminder, Amazon Prime renews tomorrow." Hey Adrian, your subscription is set to renew on February 8th, 1 day from today. Beautiful. So now that we know that our workflows are flowing, emails are sending, and subscriptions are getting created and tracked, ready for us to cancel them if we don't want to keep paying. Which means that our app has done its job. In the next lesson, let's deploy and host it to your own virtual private server. So you have complete flexibility over how you want to host it and how you want to let other people access it. Who knows, maybe even put it behind a paywall and start making some money from it. The possibilities are endless. But enough talking, let's deploy it on a VPS. And finally, we are ready to host our API on our VPS. If you followed along at the start, when I was just starting to create the API, I led you through the process of getting your own virtual private server. The cheapest plan will be more than enough, so you can choose it and enter your JavaScript Mastery coupon code, as this will give you an additional discount. So if you haven't yet gotten it, you can get it now, or if you already got it, we can continue from the dashboard. Once you're in, you should be able to find an onboarding for your VPS. If you can't see it, don't worry, you'll still be able to set up everything from your dashboard. Choose the location that is closest to you. No need to get this additional malware scanner. Here, you'll have to create your secure root password. You can click here to auto-generate it, but then make sure to copy it and save it somewhere safe, such as in our .env.development, where we can say VPS, and here I can enter my password, as well as the name, which is root. And then click continue. And since we have chosen the Node.js VPS, it comes with the latest version of Ubuntu, as well as Node.js pre-installed. So let's finish the setup. This will take a couple of minutes, so feel free to pause this video, and I'll be right back. There we go, this was quicker than I anticipated. Let's also somewhere securely store this SSH access by copying it, and then heading over into our .env and just pasting it right here as a comment. And then head over to Manage VPS. Now, in case you somehow missed the onboarding, that's totally okay, because you can change your password right here, and you have your SSH terminal here. And then if you want to change your operating system or settings, it is all here on the left. Now, what you could do is use a regular terminal, like iTerm, Bash, or PowerShell, but Hostinger also prepared this very nice browser terminal. So you can just click here, and you're in there. Once the terminal opens, you'll be able to see some information about your system, and it's going to ask you about your domain. For the time being, just simply press Ctrl+C, and that'll exit out of the setup, and then clear it. And then I'll zoom it in so we can see it a bit better. It looks like we're already within our system. How do I know that? Well, that's because if I type something like mkdir, and then the name, something like folder, and then press ls, you'll see that a new folder was created. And now I can delete it using rm-rf folder. And now ls, nothing is there. So you have a complete access to another PC right within your terminal. In case you don't want to use Hostinger's built-in terminal, you can open up any kind of terminal on your device. But how do you get from this terminal into that device? Well, you can copy this SSH root, paste it in. You can say, yes, I want to connect to it. And then you'll have to enter the password. Thankfully, we have it here, so just copy it, paste it, and press enter, and you're in. Now you can once again press Ctrl+C, and you're within the system. Either way is fine, but I'll be using the terminal built into the browser. Now, first things first, as a recommended practice, we want to update all of our packages installed on our VPS computer. And you can do that by running apt update and apt upgrade y. This command will update all the packages, and it'll also upgrade all the packages on a Debian-based system. And the Y flag automatically confirms the upgrade. This could take about a minute, but it's good to know that all of our packages will be updated and upgraded. So let's wait until it finishes, and I'll be right back. There we go. That seems to have been successful. So let's clear it. And now, since we'll be developing a Node.js application, let's install it by running apt install node.js. If you're using Bun or Deno, you would install it here. But thankfully in our case, this VPS already came in with the latest version of Node.js installed. So we're good, and we can verify it by running node-v. If you get any kind of number here, you're good. And for some reason, this Node.js installation does not come with the respective npm package manager. So let's install it separately by running apt install npm. Now it looks like there are some problems, but let's just check whether we have a version of npm install by running npm-v. And we do get it. That means we're good. But in addition to the node manager, we also need a system-wide process manager that will ensure that our tasks continue running even after crashes or reboots and automatically restart them in the background on our VPS server in case of failure. There's an npm package that we can install for that called pm2. So just run npm install -g pm2. There we go. And on top of that, we'll also need a Git system installed so we can easily transfer our code base from our local device to GitHub and then to the VPS. While there are other methods, I found Git to be the simplest, especially for updating the API even after making changes. To install it, simply run apt install git-y. Super simple. Now head over to GitHub and create a new repo. You can call it however your API is called. In this case, I'll say something like subscription tracker, and I'll click create repo. Then open up your terminal and run git init, git add dot, git commit -m, initial commit, git branch m main, and then copy this git remote add origin, as well as git push u origin main. In a matter of a second, the entire codebase will be pushed to main, and then you'll have to grab this link so we can clone it over to our VPS machine. So back in our VPS terminal, you can now say git clone, and you can paste the URL you just copied. It'll clone it, and then you can press ls. ls stands for list, and it's a command that simply lists files and directories in the current directory in your operating system. Since we don't have a visual graphical user interface, we use it to see available files and folders. Here, you can see the folder we created. Now, we have to set up a couple of things inside of it. So to navigate inside of that folder in a Unix-based system, we can use the cd command. cd stands for change directory, and it's used to navigate between different directories. You can just start typing and then press enter, and it'll actually autofill the entire name. And press enter, and now you can see the path has changed, and we're officially within the subscription tracker. So now, if you press ls, you can see all the files and folders we worked so hard to create. Once you verify that you're in, you'll have to run npm install to install all of the dependencies, this time within our VPS. And the next couple of steps are tough, and they're gonna depend on the operating system you chose, and there's a lot of things that can break. So I don't wanna just record it and make it work for me, but then it's possible that it won't work for you. That wouldn't be a good video. So for that reason, I decided to create a completely free VPS hosting and debugging guide, where I'll list all the steps one by one with debugging instructions, so if something goes wrong, you can easily fix it. I'll link it somewhere below this lesson or in the GitHub README of this repo. You'll be able to follow along and finish it there. But with that in mind, this was a huge course, so pat yourself on the back because you built your own API. But as I said, we're not finishing here. In the free guide that'll always be up to date, you can finish this course and deploy this API to a VPS so it becomes publicly and globally accessible. Thank you so much for watching, and I'll see you in the next one. Until then, have a wonderful day.